looks like we're good. I think, let's just double check. We're good on YouTube, maybe. Always hard to tell. Live. Oh yeah, looks good. Okay, great. Close that up. All right. Hello world. So as I've written in the description for today, what I want to do is we should be okay to actually publish this package that we're working on, that we've been working on for the past, oh geez, I don't know, is it a week or something now? Yeah. Just a refresher, let's go back to our big thing here. Let's move that over here actually, and that's really, ooh, yeah. Okay, so SCTE 35. So SCTE 35 is it's a binary protocol to signal ad breaks and other sort of breaks in live stream settings. So this is for signal ad breaks. So normally what we've got is we've got, say, a computer, like any sort of player, TV, phone. Often it'll be downloading a thing called a playlist using this HTTP live streaming, or HLS. So we will get a playlist, which is a new lines limited plain text file. Things starting with the a hash are tags, and they can have a bunch of data about like what video is playing, how long the video is going to be playing for, other sort of metadata to help the player play. And then of course you'll have the actual video files, which are actually chunks of usually something like 2 to 3 to 10 seconds long. So when you're streaming something, when you're playing something, when you're receiving the stream, you're going to be downloading these things generally one bit at a time. So you're going to be doing segment 1 and then hit a tag, and you'll play that video file and you'll be seeing the stream going on. At some point, the server usually may insert a tag that looks something like this. I can't remember exactly the name of the tag, but the point is that in here is going to be our binary, well, a base64 encoded binary SCTE 35 message. So what we want our package to do is to be able to decode or encode these messages. So for example, we could read a playlist, we could insert a break if we wanted to, we could actually remove ad breaks if we wanted to, maybe, depending on how we're getting the stream. I don't really care so much about SCTE 35. It's an old protocol, I think originally done in 2001. It's really from like the cable television days, but for whatever reason, it's still being used in, if you're watching on Twitch, I'm pretty sure they would use that. A lot of other like on-demand video services like, like Disney Plus or whatever are probably using SCTE 35. So yeah, where we got up to last time was let's just do where we are today. So where we got up to last time was we added a bunch of tests. So what I want to do today is actually like add or actually find more tests from the internet, general internet. I'm not sure exactly where, but right now we're only getting the sort of tests and examples from the specification. But it would be good, I think, to get sort of like real world examples from the wild, because who knows how these messages are generated. Similarly, we want to know, for example, like how other video equipment will actually read our messages, because I know from experience that companies or video equipment vendors will say, yes, you can send SCTE35, but what that really means is that they support some kind of subset, and you often need to like mess around with your message format to actually get the thing be received and read properly in a way that it's understood. So that's why we want to add and find more tests from the internet. The wild. Let's try and find something. One of the places we could get it from is actually the other. There's a couple of other SCTE35. So we could get it from other libraries. Probably be able to get some good stuff from there. Okay, that's that bit. The other thing that I wanted to do was, we want to write say polish the let's say like the exported package interface. And what I mean by that is like adding examples so that users of our library will know how to use it, how it's intended to be used, that sort of thing. So add examples. We also want to ensure that we're only exporting the functions and the types that we really want to be exporting. So ensure we're exporting, kind of like the minimum required, I guess. In say functionality. That's fine. Once we've done that, we've polished it all up and got it so that it kind of makes sense more for people outside of this stream, even or me even, because right now it's hard to understand, right? This thing's a bit weird. Once that's good, we can actually publish the thing. So what I mean by that is actually like we'll go through a little bit of what is sort of normal publish, and what that means is moving it from in Go sort of package language stuff. It means moving it out of the internal directory and into the, in our case, it's going to be into the root of the repository. So we go from move from internal to, so a couple of directories up. That I think should be it. Now, what we could also do is actually do some kind of application testing, if that makes sense. So what I mean is like we'll try and fire up VLC, or we can just try and like make an HLS playlist like by hand. It's going to be a bit shitty, but who cares? We'll actually like try and insert some messages and see how players respond. That should be all right. So let's actually let's do like real world player testing. G VLC. We could use the Safari browser. It actually supports HLS natively. So let's just do here. So or QuickTime also works too. And we've also got a common online JavaScript package to actually get HTTP live streaming, and by extension SCTE35 stuff. We can use video.js. There's a few tests online for that. Yeah, that looks real world. It's going to be real world player testing, but also we're going to, let's say we want to make how we're actually going to make that is probably like a little command line tool. So we'll just do a CMD line tool to sort of to make messages. Looks like our plan for today. So yep, looks good. Okay, let's get going. Now I'm probably in the wrong place here. Maybe what I really want to do is open up a browser and just try to find some other examples straight away. So add more tests from internet. Yeah, because right now at least, beautiful. All our tests passing. So yeah, let's open up a browser and just try and find some stuff. So one of the things that I was told about was on, yeah, this part, here we go. It's this package. So let's have a look. This one's actually written in Go, so there's also another one written in Python. Is this the Python one? Oh yeah, no, this is one written in Python. Let's rip this thing down. I just got a new desk set up, so I gotta see get everything working. Right, here. Actually, let's go into here and then so there's already an example. Just keep that open over here. Keep browsing around to see what else is around. Here we go, juicy. Got somebody in the chat here on YouTube asking, hello, who are you? Oh, what do I, oh, whoops, okay, oh, no, they're gone, okay, I'm not gonna leave that. Okay, so what we're doing here is, looks like elapsed time, duration 15. Okay, so we could probably get some info out of here. So let's try just this one example. So apparently we've got a duration of 15. It's a cute out. So I don't know exactly what those things mean, but let's do a test with it. So we'll go. I don't know what actually that is. So let's just throw it in here. So we'll do a decode test. Oh no, this person is, okay, yeah, we'll just quickly respond to this. Sorry. Okay, question, this, somebody called Hash is here. They're asking, who am I, what do I do, and why should I follow you? Yeah, I mean, yeah, I'm Ollie. I am streaming about SCTE 35, doing a bit of a test to see these low-level video, doing low-level video protocols that are used in live streaming. Yeah, we're doing this in Go. Not so much to, you know, write incredible, really useful code or to make any money, but just to sort of explore software engineering in general, because this is stuff that you don't really see every day. So yeah, if you're interested in that kind of discussion and like just following along and hacking away, then yeah, feel free to join us. It's been fun so far. I've had fun so far. How about yourself, Hash? Yeah. What are you up to today? Yeah, nice to say hello to you too. What we'll do here is we'll just add another bit to the test, I guess. We could do a, yeah, let's just do this here. Okay, so we got here. Let's just see what happens here. So we're just going to decode it, see if it errors, just as a really quick test. Alright, let's run our tests. Alright. Oh no, let's save it. Go again. Cool. Okay, so the trying to decode that thing doesn't fail straight away. That's cool. Let's see what we get. Again, equals that if I'm getting some kind of data in there. That's cool. So to be honest, I can't even remember exactly what these structures look like. So let's start up our documentation viewer and also our formatter. All right, should have done that at the beginning. Okay, so we're going to print out all the fields of the structure, see what we're looking at. Let's print out the command. Is it a splice insert? Let's go and print out the actual insert command. And then we could even print out the duration, because apparently we're getting a duration of, I can't remember what that's, pretty sure that's 15 seconds. This is our playlist file. Let's print out the duration and see. Interesting. Okay, cool, nice round number. So that is 100, that many ticks of a 90 kilohertz clock. So in a second. So if we divide that by 90,000, then we'll get our and we'll get how many seconds that is. 15. Woo! Nice. Okay, great. Great, great, great. So that means that the splice time field, so let me print this out again. So let's just copy this. What I'll do is I'll print out the whole field. So the whole structure. So that's a command, I think. Schedule, insert, no, sorry, okay, the insert. Yeah, okay, so let's print out this splice time. So what I'm expecting is that if I go to the our packages docs, and we go to the we're looking at the insert structure. Yeah, and break duration. Okay, so what I'm expecting here is that the I'm sorry, I got a few people alrighty here. Sorry, I keep missing the chat. I've got two chat windows open. So Hash says, let's put this here. Can you see that? Yeah. I want to initially start with CS50. Oh, I guess, is that like a one of those free computer science courses online? I want to view it and start learning C and NetBSD alongside. Oh yeah, great, yeah. NetBSD looks super cool. I actually haven't played with NetBSD specifically, but yeah, I love OpenBSD. The only reason I'm on a Mac now is because I've got a bunch of, like, you know, yeah, this is just a very quick setup. I started streaming last week, so I just yeah. But I plugged this iPad in and draw on it and all that sort of shit. So is it plugged in yet? But yeah, I want to obviously use the main computer that I normally use to do stuff. That would be cool. Yeah, that I've been watching tutorials and videos for a long time. I'm still struggling to write original code. Yeah, like writing code is really hard. Yeah. I mean, I find it hard. Here's the best and also a great procrastinator. Yeah. I know how you feel. Am I on plan 9? No. I'm not on plan 9 right now, although I do have a plan 9 server running. So maybe what I should do is draw term into it, and I could actually do all of this from plan 9 now that I think about it, because there's a Go runs on plan 9, so I should maybe do that. That might be might be interesting for other people that probably don't know what plan 9 is. Very rare to see people using Acme. Yeah, I guess I guess most people use like VS Code and IntelliJ and yeah, of course, like Vim, VI, Emacs. People still use that? I don't know. You can't get out of NeoVim editors. Yeah, the trick is the Q command. Nah, just joking. Yeah, I still use. I was using VI just before. Why did I choose Go? NeoVim was getting lumped due to some influences. Ah, I see the influences. Ah, yes. Yeah, I mean, yeah, I think it's a pretty cool editor. I always thought the command language of VI is pretty cool. It's an interesting way of thinking about editing text, is using commands rather than like, if that sort of makes sense. When you start, learning the motions and stuff, like you want to delete the next paragraph just with like D brace. Really cool. Thoughts on why did I choose Go? Preference or speed? I just, I guess yeah. I totally get you. I used just plain VI, not even Vim, for years. And just at some point, I thought the ideas in Acme were really cool. So I just got used to it. I don't like having to switch between, like mouse, keyboard, but yeah, it's yeah. I know exactly what you mean. Yeah. Oh yeah, playing Vim. Yeah. Back asks, why did I choose Go? I chose, well, I didn't so much choose it as I kind of accidentally started using it. My background is not really it's not in software development. I don't have a computer science degree or anything like that. I was doing like a lot of sysadmin and DevOpsy sort of stuff. Site reliability engineering, is that the word? And so I decided I want to try to start programming. Oh, let me just put this here. Sorry, Imesh, I missed your, yeah, I need to get used to this chat thing, sorry. Yeah, but Go, how do I say? It made it really easy to write these sort of command line programs that I was using. So I'm sort of a big like Unix head, like I'm very used to writing things just like little programs that pipe text around, open sockets, that sort of thing. And so Go made that. I basically just saw the syntax, and I thought, oh wow, that feels about right. So I just started doing it like that, and then the place I was working at, they needed some software developed, and I just started writing it in Go, and yeah, I don't really think about it. But yeah, I think it's there's some amazing languages around, and having Go is, I think we're very lucky. IMH says, I wouldn't say writing code is hard. It is fun and sometimes frustrating. Yeah, yeah, that's true. Maybe reading code is hard. How about that? Code 8 to 12 hours a day, sometimes more. I've been doing so for the last 27 years. Yeah, well done. Yeah. You know, whatsoever, I just write hack shit because I love it. Yeah. Well, it's a love-hate relationship, isn't it? For me, it is. It's this morning I thought, oh man, I got to do this again, but yeah. Yeah, yep. I would absolutely agree with that. Yeah, yeah, absolutely agree. Yeah, my friend, he's a very smart guy, I reckon. But he barely ever writes code, only is reading it. And then every now and then he'll write like some tiny little script or something to um, demonstrate some kind of exploit in software. He's a fantastic at reading code. Yeah, security researcher. Yeah, especially hard when you're reading my code. Okay, let's keep going on this test here. Where are we up to? Um, I feel like just since this is a pretty simple test, I feel like I want to maybe a few new tests, or anyway, we know the expected value of this, so why don't we could make a new table of tests from this Python library. That might be good. So we go into examples, and of course we credit the author and all that sort of thing. Copyright the Python packaging authority. Miguel, would you say you prefer to read code or write code? You also ask, you can still use Vim like Acme since you can call external programs and get the standard output into the editing window. Yeah, that's 100%. Yeah, that's yeah, and I started doing more and more of that using VI, and so Vim. So when I saw Acme, I thought, oh wow, it's like really easy to get external programs to interact with the text. So I thought that was really cool. Okay, so what I think I want to do here is maybe yeah. That's cool. Oh well, I guess you'll find out if you're prefer reading or writing code pretty soon if you're doing it at university. I don't know what it's like to study programming at university. Yeah. Bioengineering. Yeah, nice. You know, that is exactly, yeah, there you go. Yep, yep. Yeah, so I also, that's cool. Nice. Yeah. I studied medical science at university, so I wanted to go into medical research. So I got the degree and then I sort of accidentally got a job in IT. Uh, yeah, I'm also streaming to YouTube because I wasn't sure what people. Yeah, I don't know. I thought maybe I should do both just in case some people can't get Twitch or to be honest, I didn't know that Twitch actually had like non-video gaming stuff on there. So yeah. Okay. That's yeah, but that's yeah. I think learning about that sort of thing that is probably at least for me, I found learning that stuff at university was really helpful because it was like systems thinking, if that makes sense. So you kind of learn like about different layers and abstraction and what's the best way to. Mm, Sometimes it helps to think about problems at sort of different, in terms of systems. You go, oh, if that one thing goes up, then that other thing goes down, and but within that system, you've got a whole other bunch of checks and balances. So I found that type of thinking really useful for software development as well. Not software development, just like engineering stuff. CSGOs, to be honest. Oh yeah, yeah, right. Yeah, I actually don't know anything about computer science degrees. I know that my friend did one. Although no, it wasn't fully computer science. It was something else. But I think learning algorithms and stuff like that does sound interesting. But I yeah, I don't know. I think the business of like what we see in the software development world and the yeah, that's I think that's its own world of stuff. I think yeah. Yeah, I guess so. Yeah, certainly nowadays with so much stuff online. Okay, there you go. Yeah. Okay. I'm going to keep trucking along with this package because I'm going to feel very upset if we don't, um, if we can't publish this thing at the end because I think it would be good if we moved on at some point past SCTE 35 and onto um, something that we can sort of play with a little bit more rather than just the messaging protocol. Oh, thanks, IMesh. That I love that you don't use affiliated on Twitch and let us better the damn ads. But I hope you set up something payable on Patreon and just we can buy you coffee. Oh, thanks. That's super kind. Yeah, nah, and thanks, Miguel. That's cool. Nah, yeah, sorry. I just a bunch of people were messaging me and saying, "Oh, this is super helpful." So I thought, oh well, then I better keep going just so so that people who watch it later can I don't know. I hope they kind of skip through a lot of stuff because there's a lot of stuff of going and then getting stuck and but yeah yeah okay yeah thanks IMesh. I might maybe I should set that up. It will make it a little bit easier. Yeah. I might yeah okay. That would pay for the yes. certainly this desk, I just got this new desk from the side of the road last night, so very happy with it. All right. Do is let's get these ones. Where are we? 3.5 was it? Do that. So that value is 15 seconds. We should do a duration here actually. That's good. That's one, and then this one should be 30 seconds apparently. So the actual, if if I open up some documentation here, it might be easy to see exactly what I'm thinking. But basically, we want to let's go here. So what we want to do is within our splice, we want to decode the splice first, have a look at the command, look at the specific command type that we're expecting, which is this insert, and then get these values and check whether they're the values that we expect. So in the one that we're working on right now, I'll just do like this, so it's a bit, oh no, that's too far, like that. Okay. Even thinner. Yeah. Just arranging stuff. So yeah, we're going to get the splice time and or the duration, and then we will so these values are actually the number of ticks of a 90 kilohertz clock. So this is this interesting sort of way of measuring durations in often like video hardware. Yeah, so we'll get that and just convert that to an actual go time duration, and then we'll compare if it's the thing that we expect, and if not, then we error out. So the ticks in each of these examples is going to be is the splice and insert to the duration, and then again we're going to go to the duration, and then the duration that we get is going to be the ticks divided by 90,000. That should compile, just see, so that's going to be a, yeah, that might, anyway, let's see how the compiler goes with that, but we might just do some type conversion there, but that's all fine. So, and we can actually call this that, and then if the not does not equal duration, then something like that for now. Let's print that out too, just for now. Okay, let's run. And 64 on time duration. Okay, yep. So we'll turn this into a. Turn it into a duration. So there's 90,000 ticks in a second. Whoa, there we go. That's great. That's what we want. This is why we do these tests. Okay, so what's happening is when we are decoding the let's get this right, when we're decoding the this should be the info, the segmentation descriptor. Okay. So if we command, okay, here. So what's happening is that we're decoding, okay, and then we get to the splice descriptor, and then we're decoding a segmentation descriptor, and then we're stuffed. So what we might want to do is actually just do some length checks here. And there's two ways to do the length checking. One way is that we can actually just ask Go, like just say, hey, like what's the length of the, like how many bytes have I got left in the buffer? The other thing that's actually documented in the spec is that, what I'm going to do, I'm just going to write this down just because it sort of helps me think about it. So what we're doing here is when we decode the segment descriptor, there's a whole bunch of bytes that contain, if I go to this segment descriptor, yep, there we go. So a whole bunch of stuff that we end up encoding, like all this. But what's happening here is that we're getting to here, and we're trying to read a couple more bytes, but there aren't any more bytes left. So we're getting a panic. One of the things that we can do is when we're decoding the descriptor, they actually give us a length at the beginning. So they say, hey, like the length, where is it? The segmentation event ID. I'll just draw it out. So oh, sorry, I just realized I haven't got, there we go. Yeah. At some point they give us a length. Now I thought we did bounds checking already, so if we, what I mean is that when we pass in, yeah, I thought we always passed in exactly the correct size so that we can't sort of go over it. Anyway, either way, we're getting a length, and then at the end we have 2 bytes that we want to read. So let's just do this. The 2 bytes we want are the sub number and the, I call this sub expected, okay. So what we could do is check the length and say, oh well, we've got an extra 2 bytes, so therefore we must be able to read the, like if the length, like by the time we get to here, which is the expected field, we should be able to check whether we've got enough bytes. And then if we don't have enough bytes, then okay. I feel like that's simpler because, you know, like looking up the length of a slice in Go, I mean, that's like super cheap. And it's easy and it's built in and all that. Yeah, we're not dealing with like linked lists or whatever where we, you know, where you don't know. So, and also we've resliced, so we're kind of, it's really easy to check. So we can just go, instead of doing this, I feel like we can just check the length. Because I don't think this actually holds. I don't think that this logic isn't correct, because we're expecting, in our particular struct that we're decoding, the value of expected is greater than 0, yet there's no more bytes in the buffer. So that means that, yeah, that's not the right logic there. What we need to do is lang of, if we've got any more from 2, is that right? From 2 onwards. Give us the slice. Let's just open up a quick 0, 1, 2 onwards. Yeah, so we'll need to go from, so the length here is going to do 2, so we'll go we can actually be even more precise, so we can say, we're going to make this short, so if it's greater than 1, then we know that, and then again, if the something like that. This doesn't seem clear to me. Because I want to, I'd rather know that there's okay, we've fixed up that, but now we're getting a totally new kind of error. I am Ash. Hey, sorry I didn't see your message before. The channel name, I don't actually know how to I didn't know you could have channel names on YouTube, but I can give you the link, I guess. Is that it? Yeah, hopefully that takes you to the right place. What is all this? Oh, wow, more. Right. So this looks all good to me now. Hey there. Oh, it's up. Wow. You're double fisting us, mate. You got two chats open. Social butterfly here. I am Ash. Ian Ash? Sorry, I don't know how to pronounce that name. Okay, so it looks like this message actually doesn't contain the thing that we're expecting. So what does it? Does it contain the... Let's print this out earlier. Let's go here. Turn it. Oh, it doesn't even... Okay, so... Alright, so this message here doesn't even contain a... Doesn't even contain an insert, so let's... Oh wow, yeah, cool. Hebrew, wow. That's a tricky language, right? I mean, for maybe for English speakers. Ah, gotcha. Okay, so that actually has a time signal. Which itself is also ticks. So what we can do here is decode the splice, and then we'll just do it. We can even just do a switch. So we go splice command type, and then is a what are we going to call this thing? This is a, it's just a direction. So in this case, we're just reading straight from, oops, sorry, you can't see that. So in this particular case, we're just going to read straight from time signal. So it's equals splice dot command dot time signal, but then we want to convert that to a duration. So it's tick. Oops. If it's a splice insert, then read the duration from I think this, yeah, from the break duration. So we just can get it from and then here we'll just error out completely because we're only testing the duration here. So just in case we add a totally new type of message that we don't support, and we support them but not testing it, not right now anyway. And we'll do the duration test. Is that the right wording? No. Yeah, no duration test supported for this command type. Yep. Go back to here. There we go. On that. This has got to be that. So oh, okay. Dereference. Okay. So perhaps in this particular test here, no, not that one. Okay, so yeah, we do actually, I'm pretty sure we do actually expect 10 seconds here. So in our so let's just double check. So this goes for 2 seconds. Let's draw it out. So in our playlist, we've got a normal video, so we'll just call it like, and that says it's going to be 2 seconds. Next in the playlist, we have a SCTE 35 message. After having previously received a message that OA2 CLS, I can't remember what that means, but maybe we should try decoding this one as well. Let's try that and see if it's also 30 seconds. Oh, this is the same. They're all the same. Is that right? Are all of these the same message? QA. No, they just all happen to end with the same bytes, which makes sense because those final bytes are just like a checksum. I do want to test this one though, like that. Get rid of that one. Let's replace that there. What's this? What? These are all the same. Yep. So all of these are the same message, which is fine. Let's there's something about the message that I'm not quite understanding. This is to do with actually SCTE 35 itself, not so much the decoding or encoding. So this message contains a I get it. Okay, I get it. So what's happening here is that we've got a total duration of 30 seconds. We've got 10 seconds, 10 seconds, 10 seconds. That's it. So the expected duration is actually 10 because we've got 3 of them. So 10, 20, 30 seconds. So this is actually 10. Yep. So let's work it out. From here then, we're expecting this to be 15 seconds. So let's give it a go. Why I say that is because apparently duration's 30 seconds, and then we've got 2 of them. Oh, I didn't copy the no, not equals, what I want here. There we go. Oh, interesting. but it is in that kind of 15-second increment that we're expecting. So it's not some totally bogus number. It's not like, 5,000 hours or whatever, which we would expect if we were decoding it incorrectly. If we were if we're incorrectly shifting bits, that sort of thing, then we'd get like some orders of magnitude difference. And this should be MUA1L. Yeah. Could it perhaps be the it could perhaps be the cumulative values from the playlist so far. No, but it couldn't be, because these are all exactly the same messages, so it's impossible for the duration to be the same. Otherwise, we'd see a different. The base 64 encoding would be totally different. So it's not that. What we can do is we can actually check this other library in Python and just see that we're getting maybe getting the expected values. They might, I don't know if we've got the testing or if they're just printing stuff out. Um, 1 minute 15 seconds 60.75. So let's look for that. There is a online decoder. JS, here we go. Was this it? Here we go. Let's chuck this thing in and just to double check our work. So this particular decoder is saying, oh yeah, it's that many ticks. So let's that divided by 90,000. $75, 1 minute 15. Okay, So, fair enough. Okay, yeah, so we're actually expecting 1 minute 15, so let's change that round. In our test, we are expecting 15 seconds. Okay, so this is actually 75 seconds. Cool. It's pretty good. Now I wonder if there are other, let's now just, so if I go back to the to-do list, which is here. I'll have a look at, find more tests from the internet. I don't know where to look, but there we go. Let's go this one. SCTE. Inquire. Seeing if they've got any samples in here. I love how people make these logos for these projects. It's so good. It's like, what? What is that? Birthday cake. No, okay, so I haven't got any tests in there, so let's samples programmatically. What? quite what I'm looking for. Just need like oh, here we go. This company deals with this, SCTE 35. This is published just a few months ago. So oh yeah, nice. Okay, here we go. Here's an example. Okay, let's get that one out. So let's copy this. What I'd like to do instead is actually sort of do a quick, what's big boy. So apparently this duration is that many. So that many seconds. So we might want to, this is a good time maybe to address the rounding and stuff like that, because, well, actually that's okay. What if we changed it not using seconds but maybe using say milliseconds, so that's 90, like that. Oh no, yeah, okay, of course, yeah, we're always going to get that, because that never goes into 90. Let's just do this for now, just to see. It's that many milliseconds. See what we get, because the whole thing might just, there we go. Okay. Decode splice descriptors unmarshal 1 supported. Just link where we got this from. Here. Oh. Okay, so we haven't done a stringer method for, well, I mean, this isn't even a type, so it's 0, 1, DTMF. Okay, so let's, what we need to do then is implement decoding of this DTMF, which to be honest I thought we did, but that's okay, this one's pretty easy. So the DTMF, yeah, so where we're at now is we're just hitting an example that uses command. It's the type of splice descriptor is actually a one that we haven't written code to decode yet. So let's yeah, as I said, let's just do that. So it's in splice descriptor. What we're going to look for is when we're yep. Okay, so let's go case tag DTMF. To a new function, so we're going to call this where is our DTMF? There we go. We might need an error, but I'm not sure what the what we may be getting. So DTMF descriptor. Ah, yeah, really easy. Okay, let's open this spec again because I can't remember. This is the stuff that we're storing, but I think when we're encoding it and decoding it, we need to have I think there's a length in there as a byte. So where's my 35 or something? Let's just get it again. So we're going to go to the splice descriptor, oh no, and then we're going to go to DTMF. Yeah, okay, here's the stuff. That here. So with these ones, we've already read the tag, length, and the ID. So next is just to read this pre-roll, which is super easy. So let's do our here. And then the pre-roll is just, we can just do this in one hit, is the uint8 of the first byte. Program with that exaggerated lights and color, nice. Yeah, I find it distracting. I don't know. Programming is hard enough for me that, yeah, it's like, yeah. And we can actually skip. Oh no, sorry, no, the length. Yeah, okay, so maybe reserved, and then just that. So we don't need the count because we're not really allocating memory. We're not writing C here. So here we can just go, the characters is actually going to be from all the way like that. So I think we can just go like that. Just say skip that. Pre-roll. Oh, okay, need to. Oh, we can just return the nil here. It's fine. Ooh, okay. There we go. There's that rounding error. So let's think how we're going to deal with that. The smallest unit of time represented by a tick of a 90 kilohertz clock. That's our yeah, that's where our rounding error can be sort of solved. So at 90,000 kilohertz is the same as 90 ticks per millisecond, which is the same as, so it's 1 tick per 1/90 milliseconds, right? So 1/90 milliseconds is the same as how many microseconds is that? So microseconds here is times 1,000. So 1/90 times 1,000 is, oh boy, I feel like I'm doing high school mathematics again. 9 times 100 is Shit, I can't remember how to say it. Yeah, 1 over 9 times is that like, huh? Shouldn't that should be a nice even number, right? Because it's no, not yet. No, it doesn't. Yeah, see, it doesn't divide evenly. How do we do that? There's going to be rounding errors here, so what we could do is write a function that actually handles the conversion of ticks to a real go time duration for us. However, that can't work either, because the duration, the highest duration that we can represent using go's time dot duration is isn't actually that large. So yeah, because it stores it as a number of nanoseconds, so, and a 64-bit integer. So what I think I actually tell you in here. X duration 290. Oh, well, that's pretty bloody big. Yeah, but it's still not. It's not large enough for us. Oh no, sorry. Wait, is it 64? Yeah, it's not, because we have a 33-bit unsigned integer, which is larger than the 32 bits that we can represent in Go for a positive duration. So that means the way that we're testing it here, yeah, it's not really. I want to come up with a that said, I mean, we can just sort of be happy that this test picked up on maybe we just leave it, to be honest. The reason why I'm thinking leaving it is because we can, well, maybe no. I think we should implement the rounding, because I think that's actually useful. Just as a function that we can. No, let's dump it. I'm going to dump it because the test is just to test whether we're, decoding this thing okay. And we are decoding it okay. We're hitting a different problem, so it's fine. As an exercise of actually making and performing the test, it was good, because it got us to write a tiny little bit of code that actually filled out our implementation more, which is good. And we have the code to do that now, and we're good. But yeah, I don't think that, yeah, it's good. I think it would still be nice to have that there somehow or another, but one thing we could do is actually add this to our, or rather the one that we had, which was, go back. Oh yeah, it is this one. So yeah, okay, here's what we're going to do. We are going to have that test. We're going to put it into our big table. And then we'll just have that testing with the rest of it. So I'm going to name it as well. So maybe we can call it DTMF. String. And we're going to write out the splice that we expect, which is going to be this thing for the most part. So let's grab all of that, and hopefully this sort of looks all right. Yeah, that'll do. Sort of. Here is value, splice command is a time signal, so the command is that value. Quite a few segmentation descriptors here, so, or descriptors. Let's just do that. What am I missing now? Ah, these things. Hopeful. Name encoded one, is that one? Name coded, splice info. Okay, there we go. It's good. All right. All right, let's keep filling this thing out. So here's our values. Ah, man. All right. So we'll just check that we're set this is going to be 92. Private indicator false. I'm not sure what this subtype is meant to be there. Anyway, we'll just come back to that. Okay, so the command type is that, which is time signal. Okay, and then that's the command done, I think. Yep. So splice info. None of those things are set. Okay, so command is done. Alright, so yeah, now we do our descriptors. First one we've got is segmentation descriptor. Looks something like this. The event ID is that. Cancel is false. Compliance is, I don't know. Restrictions. Okay, we've got web delivery allowed, no regional blackout, and device restrictions 3 is this one. Okay. Okay, next up we've got the duration. Oh no, that's not set, so we'll leave that. Then we've got the UPID. The type is 1. Which I believe is according to my table here, it's the add ID, though I want to check that just because there's a bunch of weird like deprecated stuff in the spec and variable user defined. Interesting. Use type OXOC. The segmentation UPID does not follow a standard naming scheme. Okay. It's still okay though. I mean, this just means that these are just. This is just like a custom type, which means that we don't. I think we're okay just to like append the bytes just as is and just pass that on to the next whoever's going to be dealing with the message. For us, we don't care what that is. Now it is saying here to use OXOC, so let's just see what they say there. Manage private UPID structure. Oh, okay. Well, anyway, that isn't the value that we're getting, so we want the type just to be 1, which doesn't matter, and then the field is of our UPID struct value. Okay, so we're going to have to just do some. Now is that decimal or is that 80, 49? Yeah, it's decimal. Okay, so we'll go. Just grab all of these guys. Oops. Now for some Acme action here, right? So we're going to go extract the beginning of the line and any digit, and then a colon and a space, and delete that. Oh no, we need to change it actually to a comma and a space. Dope. Oh yeah, I forgot to knock out the new line. Oh, plus. Wait, plus. Yeah, there we go. There we go. And then we can also delete the new lines because we don't care about them. There we go. Nice. Right, that's a UPID done. Next up is the type, okay? Oh, so this is the segment type. 33. We'll just do that as that. The number is 4. Oops, what's this segment? Number 4. Expected is 100. And then that's it. And then we have another one. Yep, same type. All right, so tag. Wait, spice descriptor tag to, yeah. Let's go again. Event ID is actually the same. Okay, the restrictions are also the same. Okay, the duration is actually set now, so that's we're going to 64. It's a pointer, I think. Yep. Okay. So and then we go. That's the value. Okay. Back into the UPID. The type this time is just again 1. All right. So we don't know what that is and we don't care. Well, it's private, so yeah. And the value again is some bytes, so we got 67, 49, this segmentation type is 48. Just curious to see what that is in the spec. So 48 is provider advertisement start. Okay, all right, whatever. So we'll do 48 there. Number is 1. Expected is 48. Oh, sorry, no. Expected is 1. Okay, great. And one more. I think. Splice descriptor tag of 1. Okay. Let's see what tag that is. I can't remember. Tag. DTMF. Good. Okay, so this isn't, yeah, my bad, because this is DTMF descriptor. And it doesn't, apparently we don't have any values, so understand that. So let me try to decode this message again. Let's see. Quite get that. So the length, it is actually saying the length is 10, so that means that there's more than just these 1, 2, 3, 4 bytes. What I'll do is I'll set it as just the empty struct, like that. I mean, you know, a 0 DTMF descriptor, and then, because there's nothing really we can get out of that. Finally we set this CRC is that. What would you like now? More missing braces. I hate this shit. Splice info. Oh, I'm missing one here. Hold on. Yeah, there we go. Okay, so there are some bytes set there. That's okay though. That's actually pretty good. So we are getting a DTMF descriptor, so that's great. So we're ruled. Okay, yeah, there's a lot there that's actually working a lot more than I thought. So this one, I know this already off the top of my head. This is the this weird event ID compliance flag, which honestly, like I don't know whether we even want to be like decoding that. I don't think that. I mean, I don't think we even want to store it in a struct. It just, to me, like it feels like it shouldn't be something that we're setting. It feels like something that can be calculated. I mean, I know that it's something that can be calculated based on the event ID. I just don't know what the algorithm is. But we can read that later in the spec. I might write up an issue about that or something. Anyway, for now, let's just set it to true. I mean, even just ID compliance would be better. Getting that right. Oh, yeah, so it's in all of them. Okay, so this one as well. Descriptor zeros, that's this one. That to me looks exactly the same. Oh, I know what it is. There's a, okay, yep. All right, so what's actually happening here is that we've needed the here. Be cool. Yeah, we need maybe a nicer way of the descriptors differ. So if we, so what's happening is that we're printing a diff even though there's no difference. There is, just for one of the descriptors, not for all of them. So we can probably simplify this a bit. The diff descriptors. So what we're saying here is that all of those are different. What we should do instead is actually just loop through and then see if there's a difference. That's it. That's all we need to do. And then if the length is 0, then who cares, right? It just continues on. So here is going to be if get this diff descriptors. Easy. get all of that. Great. So again. Yeah, fantastic. Yeah, that works. See, so we're only printing out the actual stuff that is actually different. Yeah, that's from a different part of the code that we just tidied up. So that's great. So actually that test code is quite a lot shorter now. And let's see, DTMF descriptor. Okay, so the values we're actually expecting are those 49, 53, 48, 42. So that actually in ASCII would be yeah, 59, 49, 53. Yeah, okay. Yeah, right. So this is the older actual dial tone stuff. So what we can do is we can actually write something that we expect that kind of makes sense. So we're going to do the array of byte of this string, which is actually like a dial, you know, like numbers on a telephone. Crazy. All right, so let's go. So we got the numbers are 49 is 1, 53 is 5, 48 is 0, and 42 is star, 150 star. So oh, oops. Yep. Oh, shit. What? Oh, no, we're good. Okay, yeah, we're getting a different, yeah. There we go. There it is. So that's the oh no, I haven't. 42 is star. Subtype data differs, the segmentation descriptor. Oh, sorry, no, this is a different one. Okay, so the segmentation descriptor is, might have gotten that wrong. 54, 52. Okay, so I'm wrong. Subtype is none, so let's just double check that. Private indicator, section syntax indicator, section length. write this. Yeah. So the value of the constants are, let's see, so we've got close over 0. So we decoded, oh, it's saying we actually decoded none, but we expected close gop, which is 0. Yeah, no, but it's not. The values, I mean, I saw it in the hex is actually subtype none, so let's set that in the splice info. Is that at the top? Yeah. Oh, sub none. Okay. Now it looks like we need to implement the DTMF encoding. So we're decoding stuff. We can knock out that test because we're already testing it in here with a whole bunch of other stuff. Yeah, great. Okay, so the encoding DTMF is failing, so go to our encode code, encode splice descriptor. Oh, this is okay. Actually, okay, this should be a pretty easy test to fix. Let me just go to the bathroom quickly and get a coffee from my kitchen, and I'll be back in 2 seconds. Okay. Hey there. Somebody just says, does anybody know if Oliver will publish the first video of this playlist? I do not have the first video of this playlist. Because I only uploaded it to, or rather, I just did the stream on Twitch, and so yeah, and then the videos on Twitch expire after like 1 week or something, and yeah, sorry, I didn't yeah. But what I'm interested in is what about the a couple of people have asked about the first video. I wonder if is there anything that let me say, like, what is it about the first video that you think you would find interesting or useful? Because I could definitely cover it again. I could do a short. I was thinking of doing like a shorter video as kind of like an introduction to the series. Would that sort of thing be useful? Just trying to can I message? Okay, not sure what's okay, but yeah, if anybody thinks anything would be useful, that maybe could be covered in like what you call a first video, then yeah, I'm listening. Yeah, I'm gonna put my sunglasses on because the sun is just about to shoot in. So there we go. Okay, so let's keep going. So looks like we are not encoding this descriptor correctly. Let's see. So we've got the pre-roll plus count plus the characters. No, sorry, this is the whole info is different. Oh yeah, and looks like, you know what, we're missing, looks like we're missing some bytes as well. So let's see, let's just put this to, yeah. So we're missing 2 bytes somewhere. Oh, there we go. Zero, zero. There we go. 0. So 10A. Zero, 8, 0, 3, 1, 5, 3, 4. Oh, and then the and so then the checksum is also different, I think probably because of those 2 extra bytes there. So for some silly reason we're throwing in 10, 10, so we've got a couple of zeros in there. I know what it'll be. Could be something to do with the segment number. So I've got these things here, and yeah, pretty sure that'll be it. So I think that these values should only be encoded if, we should only include these bytes when we encode only if they're greater than 0. Again, yeah, see, so it's this point. So before the, so if I just go to the, if I do a diff of this, we can see the change that we made, which was, so this logic, if the expected is greater than 0, that isn't really, like that doesn't make sense in terms of the specification. You can still, you can have the expected be greater than 0 and then not ever have these bytes set. So what we probably want here is when we're encoding only, check if they're bigger than 0, and then if so, then send them along. So if the d.sub number is 0, and then again, shit. Okay. Oh, nice. Yeah. Okay, close. Shit, I cannot believe that I can like read the hex and be like, oh yes, it's probably there. Like, what the? Why? Why are we doing this to ourselves? Why are we learning, like, of all the things we could do in life, being able to look at hex and go, I think that might be here. Stupid. Why do we do this? Okay. So now it's just a check sum that's different. I think the length is good. These are the really kind of, now that we've implemented, like, say probably, the most important parts of the spec, we're just going into these sort of boring kind of, we're testing and finding the little tiny problems that are kind of annoying. There's no big, like, big logical puzzles or, okay, so let me check our test case and just see that we're everything is exactly the same except for the okay. Let's print out as a series of decimals. $53.48. Looks okay to me. Except that checksum. Got sort of a silly idea. Let's do this, and then let's okay, not that. So this is what we, yeah, let's do that, and then we're going to do a new file with the thing that we actually got, and then let's dump in this, and again the same. Oh, I need to put another one there. Okay, let's do diff of this file with 2. Line 89. Yeah, it's just the end. It's the only difference. Okay, so 1, 2, 3, 4, 5, 6, 7. So the final 7 bytes. Wait, 1, 2, 3, 4, 5, 6, 7. The final 7 bytes are different. And the final 7 bytes no, sorry, 1, 2, 3, 4. 1, 1, 0. 1, 2, 3, 4. Okay, so, and then that's only the checksum. So only the checksum is different. So there's something about that. So either one, two, so let's get this right, 5302, yeah, and then 1, 2, 3, 4. 1, 2, 3, 4. One, 2, 3, 4. Okay, so let's go. The value we actually got is quite different. Okay. 73E175C5. Yeah. The checksum that we calculated is totally different. It's 1, 2, 3, 4. Well, I mean, we're assuming the endiness there, but anyway. Yeah. Oh, I know what we can do. We can use the other decoder from that futsu thing. So futsu. I want the can be basics for hex or integer. Okay, so let's grab this thing. DTMF characters 150 star. Yeah, I remember that. Okay, where's our checksum then? 073E175C5. Okay, so we're definitely something a bit off about the way that we're calculating the not checksum. The CW index. That should be 0. Yeah, okay. Just trying to think of a way to check this out. I mean, we've got that file, but I don't feel like the actual checksumming, like the actual, I mean, the algorithm is okay. What I mean by that is that the all the other tests are passing. So that means that the only, yeah, so yeah, so there's something about perhaps the value that we're asking to be checked, you know, as this sort of error correcting checksum thing. So let's double check again how we're, what we're actually passing into that CRC32, and yeah, have a go from there. We're taking everything out of buff, which is and we know that the we know that every single byte is as we want it to be. So when we encode this one, we get every single byte is exactly the same except for the checksum bit. So that's a tricky one. I mean, there's this thing that's really, I mean, that's really sus, isn't it? Now, I'm expecting a whole bunch of tests to fail here, yeah, which is good. Yeah, and also the DTMF. Yeah, okay, great. So, okay, that's good. Oh, there we go. There's another one. Extra. Oh, that's. There we go. Okay. Let's start hunting. Okay, so tier, command, time signal. Oh, we're close. Okay. 255. Oh, it's that CW index again. So in this time, oh man, what is that all about? Okay. Ankit, Ankit, I will give me 2 seconds. I'm pretty sure I'm just about to find where this one bug is, and then I will come right back to your question. 2 seconds. Oh, no, CW index, yeah. Right. Okay, so the issue is that, yeah, okay, so the reserved, oh man. There's no way to, so the issue is, what, 255? Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's not, no, we're alright. 3, yeah, okay, no, so it's not the CW index, it's further along, because we're up to index command. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's count where we're up to. So we've done up to 4. Okay, and then we go to, we're appending, yep, okay, we're appending there, so that's 2 bytes, so that's 6. Quite a lot going in there. So let's print out the contents of our buffer here. And yep. And what we'll also do is we'll just limit the test to this one test, because that's all we're doing. All right. 2, 5. Okay, yeah, we're already way past. All right, so let's go a bit earlier and maybe print here. 255. Ooh, almost. Oh, here. Oh no, the length is the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So does that get us to that value 240? So let's go, okay, so 11 should be before the 240. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, okay. So it's this tier. We're doing something. The tier is not. We're not encoding the. Yeah, we're not encoding the tier correctly. That's it. The value when we decode it is XOFFF. So it's there somewhere, so the right 4 bits. Or is it here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. setting zeros here. Yeah, okay. All right, here we go. All right. So the value of CW index, depending on, yeah, okay. All right, damn, that's annoying. Okay, so there's no defined value for the CW index if there's no encryption used. So what I mean by that is that if we go here and then we read the splice, okay, so if that's false, then we don't use this thing or this, or we don't set these values, those fields. The thing is that in the other in other messages in the protocol, they will set them to all ones or all zeros. So I don't know where that really leaves us, I guess, is that it doesn't really they're not, to the specification, they're not actually different. If I do this, so, oh, sorry, if I do that, but then set a 0 byte, there we pass. But then if I run all the tests for all the different messages, then we're getting failures. So, ooh, yeah, I don't know how to, one thing we could do is maybe in the yeah, tricky. I guess in the encoding test, we don't, like, we could even just, because the whole thing is, at least certainly up to tier, is fixed length. So we know that we can just get the byte at that index and maybe just say, hey, look, like if this is, if it's not actually, if it's different, then it's okay, like keep going, and like only error if you're like really sure it's different. I'm probably gonna have to do that. It doesn't complicate the it doesn't actually complicate the implementation, it just complicates the testing logic, which I think is okay. So let's just change this comment, so toggle all bits as in the spec. So at least then we're kind of following the spec, even though that's not what necessarily we see in the wild. Again, it's undefined, so yeah. But I'm okay with complicating the test logic. Or, yeah, like adding another sort of case in there. Let's get rid of that and that. And then shit, yeah. What we got is the okay, let's just index right into the slice. So okay, so it's index 10. What was was the byte that we care about? Was index, we can just test it out. So 10. I want to break out of the test there. Like, can we do, is there a... Oh, we can just return. No, we don't want to return because there could still be other values that are different. Okay, we could actually forcefully set it like this. So so we know the values are OXFF or V1. Yeah, this is this is the way to do it then. Like that. And we can just get rid of that like that. There. And then we're going to need a bit of documentation there because someone's going to look at them and go, what in the name of fuck is that? So here we go. If the CW index is undefined, what are we going to do here? Actually, we can even be clearer just by doing the code. So what we can do here is, rather than doing that, we can say if our desired struct is actually not set to be encrypted, because that's really what we want to say. So here we're going to say something like if the like that, because that's saying that, hey, the CW index doesn't matter. So Yeah, something like that. Get a bit of do that. Oh no, we've got, okay, now we need to go all the way up here, there, like that, because we're not testing the byte slice for equality, we're testing the encoded string, which we've already set. So I think that's what we want. Yep. Oh, we haven't set B1 yet, so we can actually do that. We can do that up at the top. Yeah. Okay. Or not. Motherfucker. What are we doing wrong here? D10 is E10. I thought that's right. Ah, it's 9. Because we're one off. Or not? What? Okay. And then we encode the thing. It's still different because the checksum is different. Oh god. Man. So yeah, when we encoded the oh man, yeah, okay. I don't know how to get this. I don't know how to test this reliably. It sucks because it's a good end-to-end test, but yeah, we're just not quite getting it. Because what we're doing is we calculate the checksum. So even though we're kind of manually overriding it here, at the time where we calculate the checksum, we're still working with that different byte value, just that one byte. And so then the whole checksum changes because of course it does. So the value of our slice of bytes all the way up to the checksum is identical. 1, 2, 3, 4. Yeah. So all of that. Let's just check to confirm, but I'm pretty sure that's the case. Yeah, so let's give that a go. So, oh well, I mean, fuck it. No, okay, let's just check just in case, right? So this is the here up to 7A7, yeah, 2A, yeah. That, and then this one, 7, 2A, yep. And then I'll just put that to file, this file and that file, and they're the same. Well, missing a new line though, but I don't think diff cares about that. Yep. Okay. So it's just a checksum. Whew. Okay. We could. Thing is that we're going to want. Oh, actually, no. It's okay because the checksum code we will refactor that at some point because there's I've written an issue about that. But for now, I think we're okay because what we can do is we can actually like just reslice. So let's say we get this. Okay, yeah, here we go. This is how we're going to do it. We're just going to take out the last 4 bytes. So we're going to do this. We're going to go yeah, that's it. So we're going to go of how we're going to do that. We're going to go the length and then -4, I guess. From that to the length of tt.encoded minus. Yep. Hope we can take it. Oh no, this is going to be a how are we going to do that? Base 64, so that means, will this do the, no, it's going to be a rune, so let's just see what it looks like. You see equals and got TUWK 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Can TWK 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, let's get that out. I think that's going to be right. So. This is actually not an error condition. We'll put a log there. Otherwise, it is. so actually do it like that. Yeah, that's better. Yeah, so, and then we'll log. Yeah, great. Okay. This is such a hack. I'm tempted to not ever set the. Oh, no, we're gonna have to do that, yeah. Alright, happy with that. Tricky case. Let's commit. Damn, lots of lines of code added. Damn. Ah, yeah, but all test code, so maybe that's alright. How many lines of code we got? 136. Okay, yeah, no, that's alright. We're still under half the size of the original, which is cool. Encoding or decoding? Both. Decoding. Okay, and then we got okay, yeah, well, that's fine. actually, we're missing this one here. Yep, so it's good, we've got the source of that one. Let's remember that I didn't put the source of this one here, so the name. So let's just do this. Put up here. URL. Great. And I'll just amend that. That file. Okay. Sources as noted in comments. Cool. All right. So let's take another look at our to-do list. So, oh shit! I was almost about to write with a normal pen on my iPad. That would be sad. All right. So we've done this. Yep. Polish exported package interface. Add examples, ensure exporting the minimal functionality. Yeah, okay. This is going to take looking at our Go doc. What I mean by polishing the exported package interface is, well, the first thing we've got to do is ensure that we're only exporting what we need to. Looking at it here, we don't need to export these things because I don't think anybody's ever going to decode the descriptors specifically, since you can only ever get them in a splice info. So we'll export the type but not the functions. Shit, apart from that there's only one, really, just that decode and encode the splice info. Is that all we ever need to? Doesn't seem right to me. Let's check again the spec and just see. Okay, so the spec. Is a prototype for adding new fields to the splice info section. Okay. So the only, are these sort of, is PMT is defined to unambiguously programs complying with the standard research shall be carried in the program info loop of the PMT. Yeah, look, yeah, nah. Nah. So, it's just the splice descriptor, encryption stuff. Samples, get a third of these are examples in background rows of these examples about moving categories in the standard. Yeah, look, so to me, I think the only thing we really want to expose is the encoding and decoding, and in particular maybe yeah, I think that's it. Okay. So look, first up is this type splice descriptor. So let's not export that. Encode. You, and this is T. Okay, easy. So now if we do that, great. Command type. String, yeah, we want that. Okay, we need to export the encoding of a splice info. And at the end of all this, I really want to, I'd like to get rid of this info suffix altogether and just have splice, because that's really what it is. It's a splice command, splice descriptor. You have splice everywhere. It doesn't give us anything. Yeah, so let's go descript. Shit, I forgot what we were doing now. The encoding of the descriptor, yeah, of the splice. Yeah, encoding of the splice that needs to be exported. So encode splice info, and that's just it. Just do the info. I just feel like it's clearer. At least it's more consistent. We can always edit it later with info. Okay, great. So now we should have two functions under here, or not. Code splice info, right? Type. Ah, yeah, there we go. Awesome. Where's our decode splice info? I thought. Oh yeah, okay, so we got D. Okay, export that. decode splice info. Okay. Now to document and give an example of these things, this is really what we want. So I'll just double check that we've got everything. In particular, I would like to not export that encode event ID compliance, but I'll just make a note of that somewhere. Maybe I'll just make a quick issue about it, I think, yeah. So new ones is going to be in turn. I'm going to hide or like unexport, is that the word? Wait. That's the event ID. Oh, we got a new chat message. Oh yeah, hey, and Ankit, sorry, mate, sorry, I forgot to reply to you. From where can I learn about SCTE and what other protocols I can implement? There is a good article by, I think, Mux. Yeah. So, yeah, this is, yeah, I think it's this one. Yeah, this is, I think it was this one. If, so this is a cool article to, as I say, learn about SCTE and other protocols, because this talks about the whole kind of process from, well, the systems that are involved, the types of work that needs to be done in sort of a typical live streaming sort of video delivery system, or collection of systems. This includes things like SCTE and a whole bunch of other stuff. So I recommend that article. Can I like, yeah, nice, you can do this, okay. So I hope that's useful. Mark Ryan asks, am I going to publish day one? Yeah, so sorry Mark, I do not have the video for day one anymore. I have everything from day 2 onwards. Yeah, I asked somebody else, I'd be super curious to hear from you too. What would you like to see in a, like, what were you hoping to see in day one? Would there be like sort of a general overview of what we're doing here? Because a couple of other people have asked me about day one. Yeah, but to be honest, that day one video, I mean, that was like the very first time I ever live streamed anything before. So, but anyway, it was on Twitch, but that's expired now. Yeah. Let me know if, certainly I would like to make sort of some kind of introduction sort of video, probably a shorter one that just talks about, you know, like what this SCTE 35 thing is. But yeah, let us know in the chat. Okay, yeah, cool. Hey, look, listen, don't expect any big masterpieces. This is very, I mean, Yeah. Okay. Yep. Yeah. Well. Yeah. Everything is there in the sense that, like, you'll see a lot of me just going, shit, fuck, So, yeah, it's totally unedited. So, yeah. That's but yeah, that's interesting. Thanks. I'll yeah, let me see if I can put a quick sort of intro video together. I recorded something yesterday actually during the stream that I should probably like cut out and use as an intro. But yeah. So might I'll upload that when I've made something like that. All right. So what was I saying? Yeah, the exporting stuff. So we've got our encode, decode. Yeah, that's right. I was going to write about this ID compliance. There's quite a few of these around. Events. Yeah, right. Calculated. So the event, the fact, yeah, that flag only really says, hey, like the event ID has a special form that is that carries significance, not just some arbitrary number. So like the actual format of it, like if you split it up into bits, you can sort of glean some kind of information from it. So it should be calculated from the associated event ID. And then I don't even think that we should even store the value as a struct. Need to have the field, or any the field exported or not in the struct. Okay, the relevant structures are, just list these ones out. So it's GID comp. Here, event. Insert. And segmentation descriptor. You're thinking like, why am I writing this even though I'm the only one kind of like reading the code, or at least right now, is that when you come back to this in a week or 2 weeks or whatever time, it's just so much easier. Like you know, you really got to write even just for yourself later. So it makes a big difference. So we'll just put that. Are we good? Yep, looks good. All right, done. Great. Oops, how do I move this? Good stuff, good stuff. All right, so I'm pretty happy with the stuff that we are exporting, apart from that ID compliance and the functions. We've only got 2 functions in the whole thing. All we're doing is encoding and decoding it. Yeah. Because everything is sort of kept as, you know, they're all sort of fields, and yeah, it's all just data really. So it's just a bunch of like, yeah, a lot of data. So that's sorry about the noise, by the way. The I don't know what's going on. What? Yep. Hopefully, sorry. Hopefully the microphone cuts it out or something. All right, so yeah, as I said, I'm happy with that. So let's check that. I think we can check that off the list. Next up is add some examples. Yeah, so this is cool. So this is a good thing this is quite a cool thing in Go that maybe not that many people know about. But let's do it. So there's these things in Go called example functions. So these are just the same as the test functions that you'll see, that you'll often write. But the difference is that they'll actually show up in documentation. And secondly, they can actually be, you can actually capture the output of examples, and they're tested just like, you can actually test that the output is giving you what you want. So here we can do a thing here saying example decode. And then I think, does it take a testing? I can't remember this bit. No, what does it take? Yeah, I think it's just like this, yeah. It needs to be an exported function with starting with the word example, I believe, and yeah, let's write one. We can use let's say an example. Let's use just a shorter one, just because I'm gonna use time signal. But this is going to be a good one, so we're going to do we'll just do a or we can even just go, like that. This is just an example. And now let's encode the splice from it. So decode splice info from the byte slice, which is B. And then we can just print out something. So let's say print out. Let's print out the. Let's print out something from it. So let's choose. Let's choose the duration, and let's add 10 seconds to the duration and then re-encode it again. Let's do that. So our splice dot descriptors dot duration, and what you do is you say Mark Ryan asks, do I work in the broadcast streaming industry? I have done a few projects in that space, yeah. So that's the first time I saw this stuff. Right now I'm not, but I am available for hire, so if you have any types of projects that you think I might be useful for, then I'm good to go. But yeah, I've done a few projects, yeah, here in Australia. Jenny Long 194 says, hi, hey there. I think it's like output. Oh yeah, nice. What's the time over there in Canada? Or are you in Canada or? Not sure what the output should actually be. Ah, okay. Yeah, nice. Yeah, oh, maybe this is slightly relevant for you, or I don't know. Or yeah. We will decode. Method duration. So this is dot descriptors. Oh, I need to type. Second to be happy. Yeah, great. Okay. And then we do the output should be. Am I streaming daily? Yes, I'm streaming daily at the moment. Jenny Long. Yep, every day. Getting there slowly every day. Right, we're just going to do that. Oh wait, what's the output? Hold on, let me just check this. Testable examples. Yeah, so this is a great article. So I'll just paste this in the chat, just because this is great resource. Output. That's it. Okay. Output is. So the cool thing here is that it'll run the test and then it'll actually say, no, not. What? Output example string. Oh, of course, yeah, it needs to be in its own. I like normal test functions and begin what example instead of test demonstrates a string function. I thought it needed to be. I needed to put it in its own package. I thought I could just do it. Oh, another one. Oh no, I got it in here. Okay. So does the file need to be designing packages unscripted? And then also take no examples and test. Example across the tree, blah blah blah. Okay. V35 test. indentation descriptor. How? Oh. Oh. Yeah, okay. I knew that was... Yeah. My bad. Okay, sorry, I was... let me get rid of that file. I knew there was something wrong there. That's fine. Alright. Affected package. Yeah. Alright. Easy. So the duration needs to be a 1, 2, 3, 4, 5. So duration is actually a duration there. Dereference that. That's not going to be happy. Oh, no. Great. Okay, and then let's say put that down here. So now what we can do is you can say dur plus equals, I don't know, let's say like 10,000. And then we could probably encode it again, right? So now we go splice, blah, 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 blah. So that, oh no, that actually should be, because it's a pointer, so, oh no, we're dereferencing that. Okay, so the duration equals that. Yeah, so we'll do pointer duration, and then we plus it again, is that, and we do that, and we should get 763 10 3. Oh, yep, and then oh, that's 100,000 to 277,300,000. Now we can even go further and then encode the thing again. Oh. I play only this type of games or playing other games? Is this a game to you, Jenny? what are you doing? But they may be a bit confused by this game. Apparently there's somebody on Twitch asking what type of game I'm playing. Yeah, strange. Right, let's encode this thing again. I should base64 encode that. And base64 dot string encoding string base54 code to string. Yep, great. Okay, so what we can do, I mean, that's fine. We'll just dump that there. So what we're doing here is, yep, awesome. Actually, no, let's not even, let's just go right to the example. Index, view, where is the index, the examples? Or do I need to restart the server? I might need to do that. Oh, not usually. They will decode. There we go. Okay, great. So we've what the hell? Oh, what? Yeah, okay. I do need to put that in a new. Yeah, okay. All right. I think I do have to put it in a different file because otherwise it's gonna like use this entire. Yeah, nobody needs to see that. Let's try again. So we go new decode. I'll just do codec test. Okay, there we go, that's better. So there's an example of how to use it. In the documentation, tested, and actually tests the output of, it's actually captured by this thing. So at least we get some sort of sanity checking. Now what I would rather do here is actually maybe add 90, let's say add, that's something that's kind of an even number, so let's do 15 times 90, 1, 2, 3. So that's adding 15 seconds. By a 90, as per 90 kilohertz. Hertz? Okay, hertz, yeah, clock. Oh, no. Oh, yeah, of course, now everything's different. Okay, so I just got to change everything. That's the new value that we get. there, and that value is going to be this thing. Excellent. Yep. And we're just trusting that it can encode that okay, which I think that's a safe bet. Okay. Yeah, awesome. Just right. Save. That's done. Polish the exporter package interface. Yeah, okay. So the next thing now would just be to add like more documentation and all this sort of thing, which I'm very keen on doing. But I don't think I'm going to do that while I'm streaming because I don't think people are going to find that very interesting. I know people hate writing documentation, but I think it's super important, especially because confusing code is really hard to document. So if it's easy to document, then you know that you've got some code that is like okay or whatever, at least. Now, instead of putting that test there, what I would like to do is actually have it as like the kind of general way of using the package, because it isn't just how to use decode, it's how to use encode and modify the values, and then we'll decode, modify, encode again. What I'll do is, I think you can just call this example, and then I think it'll go to the top of the documentation. Yeah, yeah. That looks good to me. That's all right, yeah. So I think the text goes here, so it's like, I don't remember what that looks like when it gets rendered. Cool. Alrighty. So gonna say it's done for now. Alright, let's throw this thing in. Publish. Alright. Oh, this isn't correct. I need to change the import path there. Yep. So that goes, there we go. Let's open this up. looks good. Okay, let's just modify this because now this isn't a, this is not a fork, this is not anything, so. And then we don't need that. We'll keep that readme there. This is and license. Okay, and there's still, there's still more documentation. And, there's always more testing to be done. Always more testing. That doesn't exist anymore. Yeah, wow. Okay, great. So, that's cool. Let's just go back to this big screen now and just see where we're up to. Where is it? Yep. Over here. Published. Cool. Okay, real world player testing. Okay, this could be good. I think what we actually need first is a command line tool to make the messages in the first place. So probably let's just swap these around. And this is all just, whoops. I'm done with all this. Decode, blah, 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 we've done all that. Yeah, it's actually, pretty good. As an overview of what I'm thinking specifically to do next is actually, let me just quickly hop onto YouTube just to see how many people there are watching right this second, because nice to just take a quick break. Just one person, that's all right. Yeah, I might just take a quick walk around the block and then come back in a second. And then when we come back, we'll look at actually like testing this in for real with an application or something like that. It won't do anything, but at least we want to know that it, maybe matches what we see in the real world, for example. Okay, see you in a sec. Won't be long, just walk around the block, maybe 10 minutes or something like that. So I'll say, let me add some text here. How do I do that? Good stuff. Okay, see you soon. Alright, back again. Whew. Okay, so looking at the oops, oh, what's happening here? Hold on. So I just got an error on the YouTube stream, but I think that it's okay. Let me just check. Hold on. Whoa. Seems okay. If anybody's there on YouTube and there's a problem, anyway, it seems okay. I don't know what that error is, just more web app bullshit. Awesome. So we have our package here. I'll do the documentation off stream because, as I said, people probably find that very boring. Yeah, so next up what I'm thinking is a command line tool. So what I'm really thinking of is something like called, you know, like, I don't know, just something as simple as that. And then maybe what it does is you just give it a duration, like, you know, like, whatever, say 30. And then it writes that to standard output. And from there we can just, you know, whatever, like take a, maybe we get an HLS playlist. And then, you know, we write the SCTE 35, you know, we print it into that file. So we go like SCTE 35, 30, or 300, whatever, and then write that to, you know, video.m3u8, something like that. And then we play that in VLC or some kind of video player, see what happens. Yeah, let's give it a go. Let's write this. The SCTE 35 command. Let's write it up. So let's put in a command subdirectory, and then we're going to call this 35. Now there's a really handy duration flag here, but first what I like to do is just set the flags of the program. So set, it's just that, and set prefix. Actually gonna write code for it feels like ages, you know, just doing that testing for was doing testing for that our SCTE 35 package. It felt like I wasn't writing anything. I'd done most of the writing a long time ago, so it's actually kind of do something. Right, where's our go. Oh no, sorry, I want to look at the flag package, and there's a really handy flag for duration. Yeah, here we go. so we'll just do what's that, duration, okay. I don't really want that, to be honest. I really just want the argument, So it's not a flag, it is like an actual argument to the program. So we'll just do that, it's fine. Okay, we don't need any of that, alright, so I'll just do going. Okay, we've got a duration in the version type, and that's good. Let's maybe now what we want to do is just make a SCTE35 message. So we're going to go into, let's make a splice info. Okay, so splice, encrypted, no subtype, PTS adjustment is 0, city index is 0, tier is OX. In fact, I don't even think we need to set that, because they say, oh, it always needs to be ignored, so okay, fine. A command. Yeah. The noob says, hey, the noob says, asking about day one. Yeah, sorry, it is gone. I was originally only streaming on Twitch, and Twitch deletes all the, what do you call it? The videos expire after 1 week, and I only did my very first live stream of my whole life 1 week ago, so I didn't actually think anybody would watch these. But yeah, sorry about that. I'm actually, yesterday I recorded a kind of introduction to this SCTE35 series. So if you're interested in that, I will publish that at some point over the next couple or few days. But yeah, I guess, were you looking for some kind of introduction, or did you just want to start from the beginning, or was there anything in a sort of day one video that you'd like to see? Because I'll try and include that in the in an introduction, sort of like a fake day one. just post it in the chat, or also feel free to email me. Oh yeah, here we go. What's the design process? Yeah, okay, cool. Yeah, definitely. Okay. Yeah, I'll yeah, okay, cool. Okay, yeah, let me just write that down. So it's design, yeah. I'll do that. Oh yeah, let's do design process, yeah. Will do. Cool. Thanks. We probably don't do enough testing here either, to be honest. So it's going to be just the unit 64 of duration, and then okay, so we've got our command time signal is pointing to unit 64, which is the number of ticks. Yeah. Okay, so let's just do that. Now it's not, of course, it's not that. The ticks is actually the number of seconds times 90,000. And then can we do this just in one hit? Can we do a unit 64? I don't think you can, yeah. Should be alright. Anyway, okay. Command is done. Let's keep going down to. Actually, let's just do that. Oh, it's not equal now. And then we'll print a base 64 encoded string to standard output. So let's just do that. Base 64 standard encoding. Is that a command? Let's test it out. Oh no. Where did I write that? New UN64. Hey. Whoa, what? oh, this needs to be, yeah, okay. Let's chuck that in splice info. Oh, yeah, okay. Cool. Command is a pointer to a SCTE35, and that's a SCTE35.time signal. Oh, less than 2, or if then it's actually has to be exactly 2. Okay, great. So now we can say the number of so now we can just set any sort of seconds that we want. So oh, let's run a command. So let's do this. Let's do 30 seconds like that. Cool. Let's get an HLS playlist. There's a one that is always good fun for anybody who doesn't know. The classic is the Big Buck Bunny. I think everybody who's done video work will know about this thing. Where's that test stream? There we go, yeah. No. Where is the test streams dot where is this test? Oh, hold on, I think I actually saw it. Yeah, test streams.mux.dev, yeah. Yeah, nice. Okay. Okay, so what we're going to do is more Acme stuff for anybody who's interested. So from the whole file, any line that does not begin with a hash, we're going to insert this URL so that we get the thing that we want. So because right now we're not going to be able to read those a player won't be able to read the files if it's reading directly off disk, because it'll try to get to, it'll load that. It needs HTTP URL there. Okay, so streams, there's up this, oops, slash, so add insertion, discontinuity, blah, 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 slash, and then that think that should be right. Oh no, this is any line at the beginning. No, that's going to change everything. What we want to do is oh, I know. Okay, we're going to do edit every line that, no, everything that has the .ts in it. We select the whole line. Then we extract the beginning and we insert there that URL. Something like that. Oops. Might work. Oh, yeah, nice. Okay, somebody might enjoy that. A lot of people are asking about Acme, and that's what that tweet was about, so I hope somebody enjoys that. Okay, so I think now I can just open QuickTime and like play that file. So if we go to streaming, oh, doesn't let me play that. Okay, I'll need a, all right, I'll serve it. I'll just start a little web server then. Yeah. Here. /key.json. Oh, so it's going through each segment and key 1. Is it retrying? Yeah, okay. All right, let's kill that. Okay, so to 9.json, insert this URL again. Get the slashes. Getting more Acme fun for anybody who likes that. All right, let's try again. Nice. This is, so it's taken almost 10 days, but we're finally actually looking at a video. Which is good, it's funny. Oh. Right, so that's good, but I want something easy. So let's load this one. Oh, let's get this thing. bunny 480p dot m3. That looks pretty easy. Yeah, okay. So we got that. Let's get our let's fix this up so that we have the let's put this over here a bit more. Big buck bunny. Anything that starts with URL, insert that. Let's get that and that, that, and that looks good. So now, cool. Look something up. Oh, not happy. Whoops. What we want to do is not append that. We want to insert not the M3 UA. Look at it. URL underscore that. Yeah. Let's try again. There we go. See, and there's us downloading all the. This is actually, you know, I always feel like I should have started like this, just to show like, hey, like this is video streaming. This is sort of how it works. Yeah. Anyway, whatever. We really went into the deep end of like going straight for this like really shitty like ad protocol of all things. Cannot believe it. Okay, sweet. All right, so we're doing that. That's good. Let's load this our bunny up in VLC. I wonder if you can just play the file straight up. Very cool. And then we can look at the errors and just see nothing. Video messages. So weird. I can, even though I can't hear the music, I've just heard this video so many times that I like I hear it and go, oh yeah, that's the music. Okay. This is actually one of probably the most interesting bit of the entire stream, and I don't think there's anybody here. I'm thinking whether I should just wait or something. Because, yeah, I don't know, like maybe people have questions or something. I'll just quickly check who's on YouTube. Is there... Oh yeah. Hey, Emily.gg. Oh yeah, there's there's a few people in YouTube. I don't know how to see. Oh yeah, just one person. Yeah. Hey. Okay, well, if you're interested, Emily, we're gonna try and do this thing for real. So what we've got here is we have our playlist. Now what we can do is start inserting messages like SCTE35 messages that we've been making into here and just see how the whole thing behaves. So problem is I can't remember exactly what the HLS tags are, so let's have a look. HLS, can't remember what the RFC is. Oh yeah. Which one is this? Version 7. Okay, well, oh, is it all version 7? Is that how it works? I thought that, okay, so version 7, okay, anyway, sorry about that. All right, so let's, in the HLS spec, they're actually, oh yeah, maybe Dash Clan was a lot of fun, never had to touch SCTE though, so maybe I'm lucky there. Maybe. You might know then there's a tag in HLS that yeah, date range, that's it. Yeah, I was actually thinking of writing an HLS library after doing SCTE35. Ah, nice, there we go. Q in, Q out. Ah, yes, okay. Q in, Q out. Yeah, where is it? Q in. Look that up. Yeah, I've seen that one too. Exit Q in, Q out. It's been a while since I actually did this now. I need to. actually an example there, or is it just dots? No, but I've definitely seen that one. I just can't remember where, how they fit together. Because you do have a queue in, and then you also have. Yeah, I also don't see it in the spec either. Scotty said how that equals something, so let's have a look at that thing. Works out. Let's just have a look at this. So probably what we want to do is let's just try and insert a null SCTE35 command in there. I want to execute code in the same idea true, which must be unique to that splice out the splice missing no unique case must be placed in this code, which is formatting a SCTE35 in. Let's chuck something in right here. Oh no, I think it needs to be after. No, let's put it right here. C, X, date, range. Yeah, I don't know. I think the whole thing is super clunky. There we go. Let's chuck this in, just to make sure we're getting something, and then let's get some other. Yeah, that's a good point. That's a good point. Okay, let's get rid of these. And then let's just try and find some other TS file. So oh yeah, this has some, I think. Australia. Nice. Mm-hmm. Cool. Okay, so here we have a, whoops, how long was this? 60-ish seconds. Okay, let's call it 62 seconds. So what we're going to do is, let's actually move that to fiber infra. No, don't actually have fiber internet here. They are rolling it out though now, but here my speed is I get 50 megabits down and 20 up, and the ping to, if I go to, you know, Twitch, oh no, they don't know. Yeah. Oh, there we go. Yeah. So I was just thinking what I was doing. Oh yeah, I want to move the file. Yeah, okay, so and then we've got that. So let's go start date. Who cares? Plan duration is going to be, let's do 62.000. Let's do 62.0. Okay, and then we're going to go actually let's do it in DLC. Okay, here we go. I think we should get it at 20 seconds in. No. That should just be the first file. 20 seconds in. Great. Okay, so that's looking it's looking good. So next up, we'll do is maybe yeah, maybe just double check and get a different or at least that's got to be 35Q. That and that. Give this thing a go. This one. some really cool tooling by this person. Really cool. Yeah, that's actually what we could do. We could do an immediate. That is really what we want to do, isn't it? So we could do a time. Close that up. Let's open. And then it's 3035. And then let's go to immediate. That's the one. Okay, so apparently we can do a really simple splice that looks something like this. We're going to do an insert, and then it's going to be a insert, and we're going to use the insert command, and we're going to set a bunch of parameters here. So ID can just be 1, and then the duration is going to be oh no, apparently no. How does it look like? The break duration, yeah, is 60. Okay, so, and then there's no duration flag is true. Yep, okay. So we can make the duration is, shit, I forgot already, where does it go? Fuck. This thing. Duration is UN 64. Okay, easy. All right, so duration will be ticks. Oh, no, sorry. Again, will be a break duration true ticks. Check the insert command again. Oh, 35 dot. Oh, the out of network I think needs to be true. Yeah, yeah. Let's do that. The subtype needs to be set, so in here, subtype, sub none. And the ID compliance I think needs to be set as well. Okay, so the compliance is also true. Great. Now let's get that into a playlist. So let's just see what that should look like. Further. have a look at this one. So we set the discontinuity, just say to the player, hey, like, you know, there's going to be something weird coming up next. And then yeah, okay, so let's do that. Q here, and now Q equals this. Oops. And then Q out equals yes. Something. Oops. Yep. Oh, Q out equals, oops, sorry. Yes. Okay, and we're going to, I don't think there should be a space there. Let's do it 62 seconds because we know exactly how long it is. All right, there we go. Time to go. Can't read TS packet, draining on discontinuity. Oh, let's see. Oh, wow. Yeah, nice. There we go. Here's our ad break. We got it. We got our ad break. Oh, look at that. Sweet, sweet ads. Sweet, precious ads. So this should go for 62 seconds and then go back to where it started from. I don't know whether we needed... Yeah, anyway. Just sit back and enjoy this for a minute. How cool is that? Oh, I froze it. What do we got here? Ooh. Oh, yeah. Oh, man, I'm freaking out here. Oh, see, this section too long. Whoa, okay. That thing freaked out. So what I'm expecting is that we need a... Do you need a... I think in the HLS spec, yeah, this is the bit where I'm a bit out. Like the HLS spec, I think you need a... I thought you need to kind of like go back in. I thought you'd sort of discontinuity end or something like that. But I can't remember. Where's the RFC 82167? No, we don't want that one. The client must be prepared to reset its parser and decoder before media segment on the flag goes. Yeah. I mean, look, to be fair, I did download like a totally random transport stream file, MPEG file. So let's go there, 8.10. Ah, yeah, that's what we've got. So a Q. So this is a Q. Q out. Yeah, that's right. Well, that's okay. So no, I guess there's no. What do we need back on the other end? We might need a Q back in. I thought the player handled that though. Maybe it doesn't. Q out equals cons. That's XQ. In to indicate. Oh, come on, this documentation is like fucking 500 pages. No, more than 500. Did it hit 1,000? Hits 1,000. Nice work, AWS. That's great. Okay. Nah, we just need this. I thought we might need a queue back in again. Sorry, I didn't think we needed a queue back in. I thought it kind of like just handled it, but. Here we go. Replaces execute out queue. With executing the output manifest discontinuity tags microphone by add one add transition when add transmissions back to the okay, so we need this again. My bad. So let's do this. Yeah. Let's give it a go. Okay. I'm gonna play some video again, which is very exciting. Like we've been doing all this work and never seeing a fucking video. Yeah, let's go. Okay, so after about 10 seconds, we get slammed right into an ad. I think, or 20 seconds. Yeah, and then let's, oh, there we go. Okay. going. So last time we did this, it couldn't get back into the video. It had a big freak out. I think I know why now. I mean, I know why. I know certainly one thing that would have freaked it out in terms of decoding the MPEG transport stream, but not HLS. I'm not super familiar with HLS. I've done a bit of work with MPEG TS. Let's see how this thing goes. Sort of hoping it goes back in soon. I don't want to watch ads forever. Oh. Oh, yes, there we go. Right back in again, and then the timestamp and everything. All right. That's great. Okay. Whew. Can't believe it. I hope that was showing up okay. Yeah, it did. Okay. All right. And oh shit, I haven't checked the chat in a while. Oh, hey again. Hi. Hey. Sorry, I didn't see your messages. I hope. I don't even see timestamps on the messages. I'm not sure. Nice. Oh, okay. So it must have been recently. Yeah. Add more tests. Yes, added. Yep, a few more tests. Yeah. Where's our? I had a. Yeah. This is our progress for today. Sorry, that's quite messy. And we are just going through. If I can find my pen here. We're just doing this here. As you can see, we've actually got a video playing. So after over 1 week of just looking at binary and hex, we're actually doing what this thing is actually about, right? Which is watching animated rabbits and then getting rudely interrupted by some bullshit. Here to follow up on multicolor data's display integration. Yeah, that actually would be a good idea. Yeah, but I'm so those color outputs for the like the terminal stuff, like terminal escape codes and ANSI stuff. Yeah, virtual VT100 escapes. Yeah, I'm not so good with that sort of thing, but it would be really handy. Yeah. And now for the ad blocker. Yeah, that's right. So hopefully, it looks like we've got a problem here. But maybe that hasn't got to do with me. It is, yeah, it is good to see the something doing something, right? Yeah, absolutely. Whoops. Oh, did my internet drop out? Oh no, we're still here, I think. Oh yeah. Are we still? Are you okay? Oops. Ah, it did blip. Yeah, okay. Thought so. Yeah. Okay. Yeah, we're good. Thanks. Yeah, so that's great. That works. Didn't really expect that to work, but it makes sense. We're not doing any really fancy, complicated messages though. But as a proof of concept, I mean, I'd say the concept has been proven. Definitely write one of these from scratch and actually have it signal ad breaks in a video. of so glad that they've been, yeah. I think, so we can dump all that. This is an exercise. Let's go all the way back to 20. Yeah, there we go. Okay, yep. We go back. Let's watch it. Let's freak it out a little bit. Oh, there we go. All of this stuff is from the actual MPEG file, so nothing really of interest to us. I wonder, and this thing we've already done. Since so Assad, yeah, no, the idea was just to write the library that could actually do something like this in less than, 4,000 lines of code. And what we'll do next is play this in QuickTime or Safari, same thing, just see how it runs. Okay, cool. And we're back in again. Great. So, yep, good stuff, good stuff. Let's try in Safari. We're going here, we're going to play the one with the... okay, sorry. Yeah, okay. Why don't I go through exactly where kind of the latest progress. So, because this is the first time where, the library is actually being used in an application, a very shit application, but hey. So let me close all this and that. And here you go. All right. So get my windows right. Okay. Let me open these one at a time. And I'll just hide that for now. Okay, so here is a HLS playlist. So how this one normally works is let's say you go to your browser and you browse to the wherever, and then now we're reading through each of these files. So each of these files is a 10-second long chunk. So right now we'll be reading from the second chunk now. And so the player does a whole bunch of stuff to, like it doesn't just read them one at a time. It loads things in the background and does a bunch of buffering and stuff so that it can play smoothly. Now, we know, unfortunately, that watching video isn't always as smooth as this. Often the actual, media is produced like this, but what, people, who work in the business do is they want to insert ads in. So how you actually do that from an HLS perspective is here. So this right here is the same playlist, but we see we got 10 seconds file here down to there. This here is a message to the video player saying, hey, there's going to be a discontinuity in your playback, as in stop your current decoder, start a new one, do a whole bunch of magic, super tricky stuff. And then there's going to be another thing for 62 seconds. So what this here is actually, this in here says, hey, the message that we used was this one here. So we're inserting, we're kind of like cutting the video, and we're saying we're putting in a ad break of duration, and when we run the command it was 60 seconds or 62 seconds. And we're saying do it immediately. So this is kind of a bit of a very silly example, but I mean, it works. Why we've got all this other stuff is that 62 seconds isn't how the video works. How, at least with this sort of video, the whole thing operates in terms of these hardware clocks that run, well, at least it's referred to, referenced as a hardware clock running at 90,000 clicks per second. Or is it 90 kilohertz? Yeah, 90,000 clicks per second. So part of what this library does is it takes a duration that we understand, 62 seconds, and turns it into a duration that the video hardware and the software as well all understands. Yeah, so we've been playing our regular video. Let's now play the playlist with an ad break in it. So we're going to open our playlist from our server running on our computer. What's it called again? That. Okay, here we go. So we're about 10, and what we've done, if you remember, is we've done 10 seconds, and then we hit an ad break. So we should be getting an ad break in about 3 seconds. There we go, good enough. Here we go. Now I've just picked some random video off the internet, but yeah. Probably shouldn't be showing this copyrighted stuff, but whatever. Now we've said it goes for 62 seconds. Yeah, that's right. Yeah, that's a really good point. I'll just wait for this ad to end, and then yeah, that's a super good point. Thanks for that. Yeah. Okay, there we go. And we're right back to where we started. Cool. So we have here Rebel Elder on Twitch. Raised a really good point, is that this all seems kind of clunky to use these binary protocols and all that. But the trick here is that it's super low latency, and the way that all the hardware is designed is to be able to do this in a very short amount of time. So for example, it's not just used for ad breaks, but let's say you're streaming you're actually broadcasting a live event like a football match or a soccer match. Let's say somebody runs onto the field naked, or let's say, I don't know, like something like that, okay? Somebody runs onto the field naked. You can hit a button, like an actual hardware, in a big studio, and say, bang, okay, go to ad break instantly. Because this playlist file itself can actually be streamed. So, as you know, with sort of computers, we can read files line at a time, byte by byte, whatever. So you can serve a playlist and have it change pretty much on demand. So that's the idea is that you go, say you've got a kind of, what the playlist should be, but you can have like a team of people, or I don't know, some kind of production environment where you're, sort of cutting things up live. Okay, go to commercial, okay, come back again. Just like on Twitch, people do that. They have like an ad break button, I'm pretty sure. I actually saw that for the first time yesterday, I didn't know. But yeah, so when in the web interface, when you click, go to ad break, what that probably means is that the HLS playlist that that your computer is reading and rendering the files from, it will hit a SCTE 35 thing and start to technically make a platform like with it. Yeah, that's Yep, and it's a lot easier than it used to be in the old days with all the now that it's all IP and we've all got really cheap computers and they're really fast. Yeah, like doing this live production stuff, I mean, is I don't think it used to be that easy, at least when I used to go into when I go into real TV studios. Wow, like there's a lot of hardware, but we can do all of this in software. Again, it doesn't actually need to be ads. It can, you can do like cut to really anything that you want. Maybe a very important announcement from, the president of, some tropical island. Okay, so Rebel Elder on Twitch. Owncast.online. Yeah. Now this one, yeah, I've actually heard of this. Yeah, cool. I heard of this because I was writing a bit of stuff for using the activity pub protocol, that Mastodon and stuff use. I think this one hooks up to Fediverse things. Oh yeah, here we go. Yeah, that's cool. Yeah, my fingers are crossed for the Fediverse stuff. I kind of, yeah. Yeah, that's very cool. Yeah, I should. Oops. Oh, right, yeah. Yeah, very cool. I was actually how this stream is running now is I'm just running a little ffmpeg command to kind of like simulcast out, but I should really also, you know, like have a little RTMP server just, you know, on just here. I've got a tiny little server running. I should do a direct stream, because I don't, you know, my shitty internet bandwidth could probably only handle, I think, 3 more people watching, but that's enough. What I wanted to do was try just see how QuickTime behaves, just in case. Oh well, it doesn't behave. Interesting. 3U, is that correct? M3U8. Yeah, interesting. I'm just seeing why we're not playing this here. Version maybe. That's weird. Okay, I'm not sure why. Oh, there we go. Yeah, it's weird. It's funny, given that, you know, given Apple, you know, they've HLS is their thing, right? It's just weird. I feel like, I mean, I've tested. I used to do a lot of testing in a few, yeah, exactly, in quite a few different things, and yeah, that's right, yeah. It's weird, like I don't. It could be something to do with the. Anyway. Very strange. Target duration is 11. Let's see what's in here. H.264, okay, so what's the, and we go MPEG transport stream. All scenes, Seems okay to me. I'm not sure what the... Interesting. And the web server, it doesn't even try to download any of the, yeah. Just reads the, something in the, there could be a, what I feel like it could be is maybe an invalid tag. So say I do this. That one out as well. That one, oh no, that's out. Get rid of the discontinuity. Oh no, it doesn't. Oh, we're getting redirect. Oh. Huh. Well, I mean, I guess in the sense that this one plays okay. So yeah, I'm kind of missing something. Have I? Oh, there should be 3. Huh. 300. Yeah, I'll need a. Yeah, that'll do. Oh, go to Akamai. Oh yeah, I don't have a. Yeah, I just changed it around. Let's see. Between this and the other one. Oh, I've got a bad line ending, of all things. Line, what's this, line 15? Oh yeah? Or not? Wait, we got it? Yeah. What else we got here? Oh. Hold up. Let's get this out here, and then oh, whoops, that, yeah. There we go. Okay, there's a valid file, and then what we're going to do is, oh yeah, okay, and then we're going to dump in this. So yep. That's right, snapping is strange. Okay, I know. So in QuickTime, I think what it is, okay, is that the this tag, that isn't a like that isn't spec compliant. So there's no such thing as that in the RFC. Yeah. Oh. So if you go EXTX, what is this? Scuddy, and then Q, all those things don't exist. It's only supported server side by like some different sort of hardware and stuff like that. I was reading at what AWS, like some AWS, what is it? Media Live and Elemental. What they do is that they will, when they play out stuff, they convert these tags into date range. So that'll explain that. Yeah. What I would like to see though is actually maybe using date range. So let's go there and let's do this into here. Oops. Okay. So here we'll have that, and then we're going to do a here, and we'll do ID, whatever. That's 62. So what we'll do now is just convert our, right now we're writing it as base 64. Let's write it out as hex. I think there's something in the standard library to write hex strings. Oh, hold on, no, of course there is. We can just do printf. Good old printf. And the now this actually should be 60. Oh, let's get rid of that. All right. So this thing here is going to actually be down here. Oops. I'll double up here. Plan duration is this. Blah blah. Scotty 35. Out equals that. Let's give this one a go now. This may work. May work. So what we've done is we've made a instead of using the this sort of non-standard Scotty 35 HLS tag, we're using this standard date range tag. Oh, sorry, and then I need to put it in there. There we go. Now, I mean, is this going to work? No. EXTX date range ID equals. Oh, and then we need to have the same thing at the end. So that one needs to be a splice out. I can't remember how to actually make that command. So what we want to do is splice info. Oh, I think it needs to be that segment descriptor. Anyway, let's just have a look. So yeah, let's just see console. It was 60 seconds and then 35 in. This is a nice, hey, where is it? Here we go. Okay. SCTE35Q in. I don't know how that works. I'll keep that. What is that? Let's have a look at the then I do, I don't care. Maybe to generate a pair of inserts, we'll need to immediate is not true. Oh, how does that work? I can't remember in the sort of the semantics of doing these Q in and Q out. I think you set the, I'm pretty sure you set the splice time, and then you, yeah, I think that's it. I think. You say the duration plus, you know, wherever we're at. So I can't remember though. I need to check this spec again. There is this. Yeah, this is it. Oh. So what I'm looking at here is whether to I'd like to use this time signal command just because we've done the splice insert thing. I'd like to try this time signal just to test the library, but I don't know how to use it quite yet. Cancel splice tag. Okay, so a time signal command does not signal a splice out of splice in. Should be. Let's go back up to the top. So a splice info section represented a hex sequence. Okay, fine. A splice pair of splice insert commands. No, okay. Next paragraph. A splice pair signaled by a pair of time signal commands, each carrying a signal segmentation descriptor, should be represented by one or more ext date range tags carrying the same ID. Let's build that one up. Let's make 2 time signal commands. Now, time signal is pretty easy because it's just a time, but we will need to make a segmentation descriptor, which is this thing, which is basically the same as a splice insert. What we'll want to do maybe is turn the take the event. Let's just make this now. Time signal is going to be ticks, and then splice descriptors. Segmentation. And the event ID 1, doesn't matter. Cancel no event ID compliance. It's true. The restrictions. So it tells us that tells us how to encode it here. God damn. Segmentation descriptor arrive in the same. Oh, out of network indicator set to 1. Okay, where's the constants? How? Oh, okay, so it doesn't matter. Okay, so let's just not even bother about any restrictions. Go down to the segmentation descriptor. That's pretty sure, so yeah, duration. And then the type. Yeah, so now we need to do all of our, yeah, okay. I remember how this works. So what you do is you do this, yeah. Okay, so we need to open the spec and get the, because all of these actually mean something, so we may not need it, but I know definitely there's a signal that says, oh, there's a opportunity to start an add here, and then there's an opportunity to end there, then there's a time to add the end there. So we'll send two commands, one saying add opportunity start, another and add opportunity end. Let's read that. Scotty 35. The link to us here. Ooh. So it's Q out, Q in. So it's blackout. It's sometimes good just to like understand, see if I understand the like the actual protocol. So you know, when you see the same thing written in a different way, sometimes it clears up what they actually mean by, you know, queue in, or what they actually mean by the segmentation. Sort of like seeing it in a different context helps understand what they're actually talking about. But I'm going to go back to the spec now. Well, I thought I had it already downloaded, but I guess I don't. Yeah. Yeah, absolutely. Yeah, the specs can be super dry and kind of, yeah, I don't know. It's like always the same thing. So you sometimes go, yeah, you know, yeah. It's like you get, oh, this is that, and you're like, yeah, but what is that? And they go, this is that, this is that, this is that, and you're like, yeah, but what is that? I don't understand. Kind of ruthlessly consistent in a way. So we're going to go semantic specific segmentation. Oh, you know what? I think we can skip the UPID thing. So we'll go straight down to the here we go. So we're going to go add a provider advertisement start. Said this a few times, really need a to name those constants. I need a table of constants, because this is crazy putting this in here all the time. But I mean, not all the time, but you know, yeah. I actually think that's it. And then there. So I'll do something like the the descriptor in is going to be a segmentation descriptor. I'm going to make 2 of these and then just send the command out. And then ID is 1. I can just copy and paste this. And the out is in, but the out dot type is that. Yeah. So the pair is going to be a pair of splice info. So it's going to be pair is a slice of splice info. Yeah, and then let's just define 2 of them. So we're going to go splice Scotty 85.splice info. All that. But not splice insert, it's time signal. That's the command. The descriptors in. Oh, it's just that's it. And then the second one exactly the same. I should really refactor this out, but whatever. Again, all the way there, except out. Okay, let's encode them. So I'll just print out I, that's fine. Getting dark. I need to some lights on. Slice the descriptor. Great. Okay. So now we should be able to put these. Let's grab that one. The duration is 62 seconds, so we'll put one here. That's, oh no, hold on. In is first. Well, okay, I should really do that the other way around, but whatever. Yeah, so the out is that one, and then we go back in that one. Okay, let's oh wow. Oh no, almost. No, sorry. Got too excited. It's Scotty. Fuck. The letter gets hit. Oh yeah, right. Yeah, but the days are getting short here now. Yeah, I'm on the East Coast. Yeah, it's 17:30 here. Oops. Go. Oh shit. Right. Actually have a project that I worked on. Oh, okay. Just gonna look at a project I worked on where I actually did all of this before. That's super secret code. Nah, secret. Just I'm not gonna. Yeah. Oh, sorry, I forgot my mic. Are you in Perth? Yeah. Okay. So as I said, sorry, I'm just going to quickly look at the code that I've written on a project I was on. So I actually did all this before, but I can't. I've kind of blocked a lot of that out. There we go. Yeah, here we go. Hey Dylan, how's it going? Oh, okay, cool. Yeah, Perth is great. So sunny. Super dry, but so sunny. Yeah, sorry everybody. Just quickly looking at some code that I've written before for work, just to see how I set the pairs of commands that you need to send with the SCTE35 thing. Oh no. Okay. Yep. So what I do is I create a splice. So I create a splice with a time signal command, and then I use the duration, provide a start. So do I go okay. So what I do in this code is I do just a single command. So it's not really we all know, we all understand. Look, I was the only one who did it, so I guess, yeah. Yeah, okay. Look, so I think it's something to look at another time. So to get something that's actually like HLS spec compliant is a different kind of thing, but what I'm looking at here is that it's all okay. Let me just close that up and come back. Where are we here? Yeah. Sorry, just let me double check. Close everything. Okay. Yeah. Okay. Hi. Okay. So what I was just looking at is something that I worked on earlier. So to create a splice. What is that? For sort of, pure HLS, we need to create two splice info. The type has got to be time signal. And each one's got to have a segment descriptor. There's going to be two different types. So the first one is going to be a type of add start, and the second one is going to be add end. Going to have duration comes from the PTS time. What was that segmentation descriptor? Shit, I can't remember. Anyway. Yeah. But getting that HLS spec compliant as opposed to like something that other servers accept or whatever is, I'll just need to look into that a bit more. And I think testing wise, it's like it's sort of been a good test because we found that it works. So if I go back to here, we actually got something working, real web player, Safari no, and we've got a command line tool to make the messages. It also works. So that's cool too. I am a little bit hung up on not being able to get that to play natively and like, you know, officially to the spec. Yeah, that really sucks. I'm still kind of tempted to try and get something working there, but I think I can do it. It's getting towards the end of the day here. It's dark, but I'm still good. Let's get it back to how we were before, just to show the people here where we got up to. There's a few extra people here now. So everybody, I don't know if we need to do another demo because there's quite a few. Yeah, don't know how many people are here on YouTube either. 5. Yeah. All right. Yeah, so what we got working today was something that looks like this. So this here is a playlist that I was talking about in the other streams. So this is something that is going to be served from an HTTP server, and usually what happens is you're kind of streamed each of these entries. So when we play this, let's just do it live, BBB 4:8 p.m. Okay, so here's us playing the video now. So what's going on here is that we're going 10 seconds, then we move on to the next file. It's 10 seconds long, so it's right now it's reading that file. And then we're going to go to (20 seconds). Now, as I said before, unfortunately, playing video on the internet and stuff is usually not so clean and uninterrupted. Usually we've got ad breaks in there. Especially for live TV, what will happen is that people will insert ad breaks in sort of dynamically. Maybe a sports match suddenly finished. Maybe it ended a lot earlier than we expected. So we need to be able to do these things live. And that's what SCTE 35, SCTE 35 is used for. So, say we've got a playlist like this. This is the sort of ideal world. But in the sort of, let's say, real commercial world, it looks a little bit more like this. So we've got the same playlist, but you'll see part of the way down, we've got this here. So each of the URLs is a video file, of course. Each of these is a tag, sort of tells the player like what to expect, how to play it, that sort of thing. Here we've got a discontinuity, which basically is telling the player to, prepare itself to stop decoders, set up a new buffer, do whatever sort of whatever's required to get ready to play some other kind of video that's timed differently and everything. Here's the thing that says, hey, there is going to be a break of some duration, and here is our SCTE 35 message. It's base 64 encoded, and we actually generated this with a command that was written using our library. So it's just this tiny little, say it was actually even smaller before, but if we make it like it was before, point being is that when we run the command, we get a base 64 encoded SCTE 35 command. So our command works like this. We run, SCTE 35, and then we give it a duration, let's say 180 seconds, and it'll print out a base 64 encoded SCTE 35 message. This is just from some testing, but yeah. So if we just go back here. So this is our clean video. Now what we'll do is we'll play our ad video. So let's go. SCTE. Just make sure everything's good. Can do this for a little while, but it should be all right. Okay, let's go. So we're reading through. We're on the first sort of segment. Oh, it didn't work. Whoopsies. Oh no, there it goes. Yeah, right. We did it after 30 seconds this time. Yeah. Oops, sorry. 10, 20, 30. Yeah, okay. So here we are. This is just some random footage from some Australian TV. So this should go for about 62 seconds. And then we'll cut back in again because we've got this, the file will be over. We've got another discontinuity thing here saying to the decoder, hey, like, I'm just trying to see the other neighbors and home and away. I think this. Oh, there we go, and we're back again. Yeah, well, there's 3 TV shows. There's Neighbours, Home and Away, and there's Big Buck Bunny. That's it, that's all we got. That other thing we saw was actually just a modern Home and Away, maybe. Yeah, so, yeah, there we go. That's our ad break thing running. Now, it doesn't need to be ad breaks. It could just be like we're cutting to a news report or, some kind of important announcement from the Queen or the King or whatever. whoever you've got. Yeah, so that's that again. Yeah, I'm pissed about not being able to do these sort of, at least not understanding the standard sort of HLS thing. I feel like I guess I just need to read. It's not really a thing you do live. Yeah, so let me just check. This is, I think we. Let me just see the progress. Yeah, yeah, that's yeah, that's definitely the thing you want to do. The only thing is that the message itself can be encrypted, but it's only using DES encryption, so super easy to break. I mean, I say super easy. I mean, can you do it in real time? I don't know. But I guess it's, yeah. Doesn't necessarily need to be used for ads, but yeah. Bit of fun. Yeah, so what we want to do is let's just fix this thing up again. I still want to try and get that right. I'm just gonna quickly look at the old project again. Damn. So what I'm doing now is I'm looking at this old code and it's using the Comcast thing, and I think, oh, wouldn't it be nice to, at the time, if I could use this one that we've got now. I mean, it wouldn't be that much different, but certainly would make the project easier to maintain. This thing's still running in production somewhere, so PTS time. Oh, okay. So one thing I found is that the time signal, I was setting the wrong value. So if I go to in the command. Yep. So this value here, that should actually be the, this isn't just number of ticks of a thing, this needs to be, here's a little bug of sorts. So we go time, it's got to be 35. I'm tempted to actually, rather than having a uint 64 there, I could actually just have a go time value. The reason why is if I go to command, this time, so this is since midnight UTC. Now, if it's since midnight UTC, I mean, we could actually just, instead, one of the things we could do is have a time signal, which is a time.time, and then we can just calculate it like just on the fly. I feel like that's almost like a better interface, because calculating, you know, ticks is easy, but this would make it trivial as a user, because then you could just do like, you know, time signal is time.now. Don't have to think about anything. Modifying stuff will be super easy. If you want to set it in the past, you go -30 times. That's way easier. Just a thought. Yeah. Yeah. Yeah, that's it. Yeah, exactly. Yeah. To do there. Looks not good. All right. So that's that bit done. So if I just go back again to look at how to do the time signal command with a pair of sort of splice infos. Yeah, so all we end up doing here is a time yeah, just a duration and a time when it should happen. So at least in this particular application, we never created a pair of splices. We just sent one, and then the server probably handled the rest. Yeah, okay. Yep, that's all that. So I just realized that I haven't been using the monospace font even. I don't think people are used to that sort of thing. Mono. There we go. Alright, so we've got our example there. Remove that. And this one. One of the things that I just maybe what I need here, just add some more to-dos. Then you do what so often? Okay, that's another one done. as I said before, I won't do the documentation because people will fall asleep, really fall asleep, more than they are now. More than they are now. Yeah, nice. Okay, so like, look, I'm actually. QuickTime Video.js. Yeah, I really feel like we need to get that HLS. The HLS, let's say, as documented in the spec, because otherwise, but now that we have this thing working, we should almost think about what to do next. One of the things I thought about doing was a HLS library. The other one was we can do like a poll, can't we? Is that? Yeah, I saw that the other day. Hold on. Oh, have app unit set to not use a monospace font or fat finger there. Yeah. Yeah, I always have it just as a like a what do you call it? I always have it set to a variable width font, like a normal font. Just what I'm used to now. Now the other thing that we could do, since it's almost the end of the stream, is just do a quick commit, and then maybe some people can help me nerd out about how to get the OpenBSD machine sort of streaming rather than this iMac. What do we got going here? Commit is different in there. I can't go. Yeah. That font is hilarious. I don't know why. It's such like a, I don't know. Probably. Yeah, I'll probably have it. But I'd definitely rather do this, all this sort of stuff on OpenBSD and then kind of, I say that, I don't know, just because. Sorry, let me do this and then. We've got readme product test. This is going to be I'm going to what I was thinking for these future streams is right now I've got this iMac here, sort of looks like that. And then that does RTMP to FFmpeg, which then goes out to YouTube and Twitch. That's RTMP2. One of the things I thought about doing was having, I might actually put this like that. Yeah, so one of the things that, so let's do this. One of the things I thought about doing was actually having my, at the moment I've just got a laptop running OpenBSD at the moment. I mean, I've got about lots of servers running it, but the one that I use the most is this laptop. I could actually do send this via FFmpeg to here, just do like a raw UDP stream. Do I work with Vast in general? Vast? Oh, like the storage? What is that, Vast? Ah, video ad serving template. Oh, yeah, I've heard of this thing. No, it's cool. Yeah, right. No, I haven't. No, it's cool. No, I haven't heard of this one before. I guess have you worked with that one? I'll just go back to here. Somebody's talking about this here. Ah, Google, okay. Yeah, I see. Put this in Firefox. Oh yeah, it doesn't even. uBlock Origin just blocks it. Oh yeah, okay. Yep. Yeah, I wasn't involved at that high level of the ad thing. I was doing something more for, I mean, at least yeah, at work, I was doing something more for live productions like sports and stuff like that. So it wasn't so much about ads as it was like having uh, the particular thing I worked on was to have something really low latency. Ah, yeah. Oh, well, I mean, feel free to use this SCTE 35 thing if it's handy. Maybe I should talk about the other SCTE 35 libraries that are available and sort of do a quick comparison. Um, okay. Hmm. Nice. So this is, maybe I'll do it like this. Oh, where am I going to get this from? What's the package? Hmm. Yeah, that's like what I was saying. I want to get rid of that splice descriptor. Everything splice this, splice that. It's like, what? Like, who cares? Yeah, descriptor loop length. Info section. Table ID is always constant, so we don't need that. That's constant, that's constant. Sap type is a uint8. Sap details. nothing in the spec about that. I suppose what SAP details, the purpose of SAP details here would be something that I'd consider more idiomatic in Go, which is the stringer implementation. Yeah, I wouldn't store that in the struct though. Section length, again, doesn't need to be exposed. That's a constant too. Encrypted packet, encryption algorithm, yep. PTS adjustment float 64. Oh yeah, okay, yeah, I mean, I think it's all, yeah, integer. CW index string, The tier string. I'm tempted to knock that tier out altogether. Command length. And the command type. Okay. So then the command length and command type refer to the command which is in name and type, which is a naming command type. Hold on, so I already have this. So the command, if we go back to a queue, is the command, okay? And a command has name and type. Yeah, again, that's more like stringer method sort of thing. Okay, yep, and this is pretty much the same. So if we go to our insert type, where is it here? Pretty much the same. The only thing that we do is that we have fewer flags because we just use the fact that if there's a pointer, or if the pointer is nil or not, to set the flags. So yeah, unique program ID, eval num, eval expected. Okay, cool. Oh yeah, this is another thing, the splice time, yeah, so it's weird that we don't program splice flag. I thought, the splice insert requires a, anyway, yeah. Time signal is a splice time, which stands out, yep, okay. Splice time is, again, that. So all of these have the type is using these embedded struct. This command type, so console into command, okay. Indented. Yeah. Okay, so our splice descriptor is an interface. This one uses struct embedding. Ooh. JSON string. Whoa. Info. Oh yeah, we've done that already. What's the other big one? Yeah, is that segmentation descriptor? That's the other big struct. It's a bit hairy. Let's look at that. segmentation, UPID type, UPID length, okay, yeah. Oh, so here, okay, so yeah, segmentation, UPID type, UPID length, okay, so, yeah. So I guess the, interesting, okay, there we go. Yeah, so that's actually returned as bytes. Yeah, okay, cool. So what this package does is it actually, we just say, yeah, just give us bytes. We don't implement any of that. But this one actually handles it. That's cool. Yeah, but the main difference here is that it's sort of exposing all these sort of inner workings of it. So I guess what they're able to do is, we've still got less code, but certainly you'd save on code by just just not just having it set in a struct. But we sort of have code that calculates it for you, so that when you make a thing like this, it doesn't, like, you don't have to set the, the length or the, this sort of stuff. And the device restrictions is a string. That's weird, yeah. So what we do here is we have like flags set. So we have like a bit field. So you can set flags, kind of like you can on a file in Unix. In file system stuff. That's cool. Okay, well, now the other weird thing that I found about this library is something that we can't see, which is, I think the other way it sort of saves on code is it actually just with something. I don't think name and type means report. Yeah, exactly. Yeah, I mean, especially when the purpose of it is to kind of like as a human readable thing, right? A byte instead of const, for example. Okay, so I asked, what's the idea behind making command type a byte instead of const? Okay, so is that, do you mean for the, for this external package, or our, for our one that we've been working on? Okay, in here, let's have a look. The command type. So in ours is command. Okay, so why are we doing a separate type when we could just use a plain uint8? Okay, yep. Aha, okay, yep. So there's two reasons. One of them is we get to use this string method. So there's a good blog post about this. So this is kind of, this is a Go specific thing. So let's just do this one because I think this one will be quick. Where is it? So I'm just trying to find this article. Sorry, Assad. I'm just trying to find this. It's a good article because it explains sort of the point of it. Stringer to go. Stringer. Here maybe. Here we go. This is it. Okay, let me just do that here. So what this is it. Yeah. Okay. So the idea here is to be able to give a name to the constants that can be printed really easily. That kind of sounds really boring, and it kind of is, but the point is that with interfaces you can just type, for example, if I just bring up a terminal, I can just type in, from the print ln, if I have my command type, wherever it is, where's the command type? Here, yep. So I could type here, command type, so splice schedule, like this. And then what that'll give me is that'll actually string splice schedule. But if it was a plain int, even just a constant, like let's say I do have a const of splice schedule equals OX04. That'll print out, that'll print out like that, or whatever it is in the decimal. So that's one reason, is to be able to do something like that. The other reason is that it kind of serves as like a documentation. So with, let's say you were writing some code, and you're going, say the CMD, TCMD for equals, let's say 1. Or then let's say we've got a command is 1. By using a type, like as in having it like this, this is maybe a bug, because maybe there's no such thing as a command type of value 1. Maybe that's an invalid value according to the spec. So like this bug is caught at compile time. It doesn't even compile. What you need to do is something like this. But that doesn't, you're not really going to do that, because you're like, well, what is a command type of 1? What does that mean? So instead, you can just do the type. You can just do straight up, oh, well, I'm going to do a splice schedule. The compiler's happy. You're happy because you've you know, it's clear. Type splice. Oh, okay, that makes sense. So it gives you a bit of type safety as well. Sorry, that was a bit slow. I just wanted to find that that article. Yeah, yeah. It's yep. It's a good one. It's an old one, 10 years old almost, but it's good. Yeah. Um, yeah. So it's sort of this sort of thing. I think this is a really good example that they give. Oh yeah, no, totally, man. Yeah, yeah. No, I mean old like sorry. What I mean is yeah, no, absolutely. No, what I mean is I didn't I just mean it's funny because I sort of forget how old Go is. So yeah, I think yeah, because I only learned it a few years ago, really, and so I always think, oh, like where's that article? And I think, oh, why is it so difficult to find? And I think part of the reason is because it's like, you know, it's yeah, 90 syndrome. Yeah, yeah. But yeah, no, that's yeah, that's cool, Asad. Yeah, how is it going learning it after 6 months? Is it going okay? Oh yeah. Oh, you and me are the same then. Yeah. I don't know. I don't know how to not build stupid stuff. The more stupid, the better, actually, I think. I don't want anything too clever. Yeah, yeah, see, so if you could, oh yeah, Assad, yeah, you'll be able to say it. Stupid stuff is the best stuff. Okay, yeah. Um, yeah. The stupidest thing I've built. Uh, do you mean stupid like maybe shouldn't exist? Oh, okay, okay. I mean, I think this thing is pretty stupid in the sense that uh, I didn't come up with anything, right? We we just read the spec, the big that big bad this standards document, and then kind of, well, if I can get to it, you know, read through and go, oh, okay, that's what our data structure would look like. Okay, so then we just slowly kind of build it up over time. I'd say this library is pretty stupid. Now another thing I wanted, actually, now that we're here, I wish I should have said that. um, One of the things of the we're going to go Comcast. Oh, is that? Here we go. Okay. This is the original package that I'd used before. Let's swap these around. So this, woohoo! So this is kind of like let's call it like the before and after, something like that. So here, for example, is our segmentation descriptor, but type ID duration, number expected. Okay. So here the UPID is a slice, but as far as I understand it, you can't have more than one UPID. Cancel type ID. So this is another one of those things is with this package from Comcast, they were using things like 32-bit unsigned integers for things that could only be 8-bit. This sort of thing, like a method called delivery not restricted flag. But if I remember rightly, not restricted flag. Yeah. So this just, all this is a, function that, right? Like it just checks if the pointer is nil. So, and then it, returns a delivery not restricted flag. Okay, yeah, like, yeah. And again, does this need to be exported? So do other people need to, do they care if I mean, do they need to have a function that, a method that tells you if a pointer is nil? Probably not. I think anybody can write that code if they need it. And I think the reality is that, you know, you don't need it, right? Because you only need to check if the flag is set when you're either encoding or decoding. The point of using an external library, or like any library, is so that you yourself don't have to write the code to encode or decode, you know, in this case, these SCTE 35 things. I'm not sure what exactly this name does. Okay, so this is another one of these things that is not really a normal Go thing. So what this does is it does a type switch on the in our case is here. Now we actually haven't defined the constants because that's a to-do which I have now written in issue number 3 in our repository. But again, this stuff, usually what you would do is you define a string method on the type, or in this case the type ID, or in our case just the type. So the way I'd refactor this is, oops, no, here, yeah, so I'd probably have something like a type. We can do this. So instead we'd have something like segmentation type, for example, which is uint8, and then we'd go and then we'd have a block that has all the, you know, this thing, you know, so it'd be like this I'd call sort of not indicative, whatever, yeah. And then you go down and you just start setting all your things. So content, ID, what have they got here? Program start. I'm sure you can see that. Oh, yep, there we go, yep. And then eventually you'd have a string method, which then returns, you know, some kind of human readable value of really what is just an integer, and then you can pass that to the, you know, the fumped, you know, then you can do the same thing as we've done up here. You can print out the values and all that sort of stuff. It's useful for logging, especially things like that. Yeah, exactly. Yeah, yeah. Rebel Elder says that they probably just converted a Java library to Go, and yeah, that's probably the case. Hey, like you just yeah, they just had some existing code in Java and then just kind of like, yeah, kind of like a translation. The result though is that there's a lot of code, and we all know how, well, I don't know, if you're like me, I feel code is quite difficult to deal with, so the less code there is, it's usually nicer. So as you can see, it kind of goes down, you know, from there. So yeah, it's part of just a quick little survey of the, now what is the third SCTE 35 library in Go, open source one. Well, at least the ones that I've found so far. That vast one is interesting. I might have a look at that, because the sort of overarching goal of, well, I mean, part of what I think would be good is to have a, with this particular this repository is, you know, to have something that has 0 dependencies and as little code as possible, and, you know, to have kind of everything in one a little bit. Not that I'm saying everything needs to be huge or whatever, but, you know, it might be handy just to have, you know, kind of like the standard library where things kind of fit together really well in Go. Maybe we could do something like that for, you know, streaming stuff. Also, I really I find Git really difficult, so the less repositories there are, the better. This reminds me of this, wow, what was that? Let me find this thing. This is super funny. Okay, here. This is good. This one. I love this. It's good, hey? It's good, it's funny. It's good. We'll keep that one in the corner there. I mean, normally I don't even use GitHub. I thought I deleted my account actually. But yeah, I usually just self-host Git repositories. Yeah, that's cool. Now, the other weird thing about this this library, foot. Oh geez, which one was it? This thing, yep. Base.go. Okay. So there's this see, this is like decode base 64. Okay, but all throughout this package we've got things like this chk or check, I guess, and all this does is it just it prints to standard output, and that's not really what we want to do in Go, or really any yeah, I mean, like, of course, print to standard output 100%. What I mean is that there's no error handling here. So any error is just printed. So yeah, there's a few, you know, Source Hut. Yeah. I've yeah, a few things on there. Yeah, and then I've got this. So we go. Yeah. Oops. Oh. Expired 1 day ago. Oh, whoops. Oh, the cron job's wrong. Anyway, whatever. Yeah, I know. It's interesting about Git and sending patches and stuff. I think that yeah, I think there's a whole bunch of how do we say, the idea of sending a patch rather than like forking, branching, request, merge. There's quite a lot of stuff going on there that I don't think you know, the idea of just having a self-contained change as a unit and then just giving that is pretty powerful. And it's not just about email or like web interfaces and all that. I think Yeah, I think there's more to it than that. I think there's something about like the way that people use like sort of GitHub as this kind of yeah, like to share a change you must upload it to a server, which I don't think is like, yeah. I think that yeah, I think that I've always run into a lot of I guess in working on projects, when even little things like when you join a project and you can't it takes like 2 months to get access to the server, but who cares, it's Git, right? Like you just, or anything, or Mercurial, right? Done that a lot of times too, where you just make a tarball of the repository and then just like send it to them, like however you want to do it, and then you're up and running. So rather than waiting 2 months to get to be able to like commit stuff, you're just sending patch files over, like I would do it over Slack. I just copy and paste the patch and like direct message it to somebody and be like, okay, here you go. For anybody who doesn't know what we're speaking about, it's the idea that so this is the last commit I made. Normally on GitHub, I don't know if people find this interesting or not. I surely not. I don't know who's watching, but anyway, point is that you can this is a file that you can send to anybody who has the who's also got the repository, and they can apply the patch to the repository. So think of this as kind of like maybe a pull request file. So it gets you everything. You have the commit title, and the description, and then the actual code change. So sending these things around is a lot faster than than doing the whole like pull request thing. I'm not sure how many people use actually use like GitHub at work or in professional sort of corporate environments. Yeah. So have I? Sorry, can you see that? Yeah. Yeah. Yep. So yeah, this is an interesting way, at least an interesting way to think. If you if you can't do it like that, then but you don't need an account, you don't need anything. You just need to be able to send them this text. That's a really cool idea. That means that if you don't have a GitHub account, or if you don't have an account on some corporate server, or anything, maybe you're not even using Git. Maybe you're using some other system and they're using Git. As long as you can generate this file, you're good to rock and roll. And generating a file, well, we can think of many different ways to do that. Yeah, anyway. Yeah, it's cool. Source Hut, how they've sort of popularized that is really cool. I think at least I hope it's sort of popularizing it. I don't know. Yeah, but I was emailed a couple of patches to somebody. I didn't even know if they accepted it, but they just applied it in 2 seconds, and there we go, to an open source project. It was awesome. Yeah, so what is going to be next? Now that we're Probably what I'll do is I'll try and tidy up more of this this SCTE 35 stuff. See if 22051408. Go. Yeah, so what we probably want to do is get rid of that. We've done a review of the existing code. We've got this thing. Yeah, certainly some documentation, and maybe then we can think about moving on to the next thing, which I guess would be like, let's do a little poll. I don't know if I can do this. Oh, it's like, which was another thing was other options are going to be can't remember. That's good. Let's do that. Shit. That's right, yeah. Transport stream, yeah. Yep. I think I'm back now. I think, I don't know if I'm here or not. Yeah, I don't know if anybody can hear me now, but I do actually, I actually did that this morning. I've got the cable just like here. But no, I don't know what happened there. But, oh, whoops. I wanted to add another option as oh yeah, you think that HLS? It'd be good to not be so stuck on these sort of bit packing stuff. Do something a little bit more yeah. What would I work on HLS? That's a good question. So what I noticed was if I go to here, so this package is actually not really maintained anymore. So the person who originally wrote it is they used to work in video streaming, but now they don't. Like years ago or something. Here we go. I moved away from video streaming years ago, and this code is directly not used by me. The project is mostly abandoned. Anyway, I'm interested in keeping the code as useful as possible. I'll keep an eye on issues when I have the time. Time is the biggest issue. Yeah, so to me that's an interesting opportunity to, you know, I think that HLS is used a lot, so it might be good to maybe have a go at doing something that maybe implements like a subset of the protocol. The spec is pretty big, but it's certainly a lot easier than SCTE 35 because, you know, it's a text file. It's you know, it's about lexing and parsing stuff. It's kind of more up my alley. I think it's also more fun because what we'll be able to do is, I was thinking of like having a screen set up behind or something and just like constantly playing something. And so when, you know, when we're writing code and the library breaks, or if we do something stupid, then, you know, like it just, that'll break, or when it gets working, it'll come on. You know, we'll have things like working on the audio versus working on the video. We'll have things like different bit rates. So at first we'll only have one bit rate, but then we'll eventually be able to do splitting the bit rates. It might be fun to, yeah, I don't know, just something like that. Yeah, it sounds like we'll do that. Now, the other thing that we should probably do is publish this onto the video dev group. why is this? Yeah, anyway, so this is a forum hosted by a bunch of people who work in video streaming. So if you're interested, I would hop on. It's this website here. I'll put that in the chat. Let me see, when I started posting in here, people were asking about whether I'd seen that library. So that's the one that had that weird check function that just printed the errors. Another one was in here. How do I see that? Yep. Yeah, so yeah, it's just gone past 7 p. It's just gone past 7 p.m. What is? Oh no, it's quarter past. So it's 7:15 p.m. in Australia. Yeah, no worries. All the best for that. That work with the ad. What was it called? The Vast and the SCTE 35 stuff. Hopefully this is helpful. But yeah, if you ever run into anything, just write it in chat or whatever, and maybe we can all work on it together or something. I don't know. Feel free to do whatever, Yeah, right. Oh, everybody votes for live streaming. Okay, well, looks like that's what we'll do. So we'll do the HLS, and then we can put it in the hey Tadrin, RTMP wasn't an option. Oh yeah, sorry, I know, mate. I wanted to put I forgot to put in the like the other option, like other, right in, right in chat. Yeah, RTMP, yeah, maybe that would be a good one. Is there let's see. Should we look into RTMP? There's other protocols now that people are developing. There's RTMP, there's SRT, there's RIST. Yeah, that's true. Yeah, that's true. I could actually just sort of yeah, do a kind of easy DIY setup. I'm just looking at the RTMP. I think YouTube accepts SR, do they? Here we go. Oh yeah, so with YouTube you can only do RTMP ingest. So they don't support SRT or RIST or no, that's good. Yeah, hey Tarun. Yeah, that's true. I know, I know. It's a weird thing how yeah, like your key is just sent over plain text. It's like, wow, it's so old school. um yeah, no, thanks Tarun. How did you find the channel? Actually, no, you know what? I really need to go because I think my phone is ringing. My girlfriend's calling, saying me, hey, like, do you want to... Yeah, no, it's definitely time. Okay. No, thanks. Thank. No, it's good. I think we all did a good job today. It's yeah, we actually played video, which is incredible after 1 week of not even touching video. That's awesome, right? Yeah. So that's yeah, all good. All right. Cheers, folks. See you next time. I'll be on again tomorrow in about 12, 14, 16 hours, something like that. See you. Cheers.